So if we are looking at this, if it is fine, leave it. Otherwise, you can. Okay. So if you are looking at this particular scenario where we are looking at AI in the context of e-commerce, as far as your curriculum is concerned, it has been divided into two parts. The first part is mostly related to the marketing part. The second part is mostly related to the supply chain part of it. In the sense, your AI is used basically for different purposes. It is quite interesting as we start looking in terms of how we understand the role of AI. Let us start with a simple scenarios here. Is this working? Okay. Now, if you remember the discussions we had in the first session, when you are looking at how AI is being deployed in business, or for that reason, if you are talking about commerce, right? So if you look in terms of the applications, one is the increase in the sale, then increase in the customer experience, we'll see that. Automatically delivering the service, that means without any human involvement, you are delivering the service. And specific to the requirements of the customer, you try to deliver the products and services, which is known as personalized marketing. And of course, it will also help in terms of improved decision making. Overall, if you look in terms of the impact, it is basically looking in terms of increasing the volume of business for the organization or the company that deploys it. A few scenarios here. Can someone try to decode what is given there? Suggestions, right? Or we generally call them as recommendations, right? So if you look at this, in fact, I just took it as a what I call new screenshot today from Amazon. So when you're talking about this small printer, this is a home printer, right? Now, when I'm looking at the home printer, what is the other product it is suggesting? The paper, and more importantly, the dust-proof cover. See, it is very much clear in terms of what to recommend. It is highly automated because if you look in terms of the number of transactions that occur, humanly you can't do it. Every time you can't look at what a person is looking for and what should I keep. That is not possible, right? So automatically you can start looking at product suggestions. Interestingly, today we order a lot of food on apps, food recommendations, supporting during the chat, voice assistants. We'll look at this one by one, but then we'll spend a major time in terms of understanding how this recommendation is going to be possible. Now, let us look at first of all what is the relevance of recommendation. If I need to really look at the relevance of recommendation, I will start with an example, then we can go back. I'll just go to an example which you will find comfortable, right? Okay, please take a look at the screen. Which is the first movie? Very good. Second one? Third one? Fourth one is also? Pushpa. Now, just for your attention, I have caught them up. Now, say for example, if you have seen one of these movies, what kind of movies can I recommend to you? The algorithm decides. And there are various ways of actually doing this. As I told you, a lot of mathematics goes to the background where you start looking in terms of finding out the similarities among the products, finding out the similarities among the products, finding out the similarities among the customers. There are different types of algorithms that are there. So interestingly, what we'll do today is, what we'll do today is we'll actually look in terms of how this is being made possible, and what kind of technology makes it possible, and what kind of algorithms are there behind this. Right? Okay, thank you. Okay. Now, just you can look at the first slide related to the recommendation engine. A system that suggests products or services based on certain criteria. Now, please find it very interesting. Whatever you are searching gets recorded. Whether you go incognito or whether you are doing private browsing, your browser fellow knows what you are searching for. The website knows what you are searching for. Your internet service provider also knows what you are searching for. So one is, I have your search history. I know more about you. See, someone who knows your search history almost knows everything about you. They very clearly know the pattern. Now, this is where actually, I don't know if you have started with the data privacy and other issues come into the picture. But from a business angle or from a business perspective, you can very clearly see that you have these searches that are there. More interestingly, your purchase history is there. What kind of products you have purchased, right? Or even what kind of products you have browsed through. Which are the products where you have spent a longer amount of time whenever you are browsing for these products? Are there specific products where you really spent a lot of time on the page? Everything is recorded. Then we will also look in terms of, if A is a customer, who is a similar customer to A? Who is the similar customer to A? That is one thing. And of course, your preferences are there. So ultimately, if you are looking at what is given here, people like you also bought this. So if you look at what is given here, these are the frequently bought items. So something happens at the back end. In fact, you have a very interesting algorithm known as market basket analysis, which is quite interesting. But we are actually going a little bit ahead of that. So if you are looking at how this is possible, we have something called as a recommendation engine or a recommendation system. There is at the background, the A that is working, which is known as a recommendation system. How does it do basically? You need not worry about the terms right now. One is what is known as content based. The second one is what is known as collaborative filtering. In fact, content based happens to be very easy, but at the same time, collaborative filtering looks at a lot of involvement in terms of the mathematical calculations. So what does it result in? You have related products frequently purchased together, recently viewed, topics for you. See, everything is possible. Topics for you. What are the ones you have recently seen, right? Every kind of information is available. The best part about the e-commerce is you need not really search for the data. All the data gets automatically recorded at the server end. The only thing is, how do you actually process this data? Maybe on day one, you have gone through big data, right? Voluminous information is there. You need to have some kind of a platform using which you're going to look in terms of analyzing this particular data that is available with you. Now, if any one of you work in the area of marketing, customer relationship management, right? So one of the interesting aspects of customer relationship management is that I try to sell more to the existing customer rather than looking at a new customer. There is nothing wrong in terms of looking at a new customer, but then it is like a bird in hand is worth equal to two in the bush. Your existing customer is as good as 5 new customers, because there are very clear reasons. You need not really advertise to the existing customer. For a new customer, I need to advertise heavily. Maybe for a new customer, I need to go with a discount. Maybe for a new customer, I need to send the salesman to basically convince them. So the cost of acquiring customer is increasing, right? In this case, what happens? You try to retain your customer. But again, the interesting question is, when I am trying to retain my customer, what are the other scenarios that come into the picture? Two major important concepts are there in customer relationship management. One is related to what is known as cross-selling, and the other one is known as upselling. So basically, cross-selling as well as upselling. Now you see this, cross-selling is that you are not selling the same product, but you are selling unrelated product. May not be directly related to this. Now in this case, you see, if you really look at phone followed by the earphones and other things, they are not exactly part of the phone. But here, if you look at the upselling, you are trying to encourage the customer to go from the basic phone to the premium phone. So that's where upselling, you're trying to create more value for the company as well as the customer, right? So if you look at this good examples that are given here, you see this, what is happening here, someone is buying product A, maybe which is a burger, they're also trying to sell them some French fries, something else, blah, blah, blah. Now here in this case, what is happening is, from a low expensive watch, you are trying to promote a smartwatch, which is really highly expensive, right? So quite interesting thing is, if you are able to convince your customer satisfaction is going to increase. It's a kind of a win-win kind of a scenario for both of you, because really if you are able to deliver the value. So you try to increase the average order value that is there. So the interesting perspective is, will all the people buy this? This is an interesting question. If I'm making recommendations, if all those who have seen my recommendations, will they buy? Even if you have a 2 to 3% or even up to 5%, even if you have this, that is enough for you in terms of your overall profit. Compared to your regular sale, if you are able to improve your sale by maybe 2 to 3% or up to 5%, that itself is enough for you in terms of converting them into huge profits. Like I told you, basically speaking, the two algorithms that are there are related to, one is what is known as a content-based algorithm, the second one is what is known as a collaborative filtering, which we will see now, step by step, nothing to worry about that. Now, if you look at from a very simplistic perspective, your content-based algorithm is based on your history. We'll see again. Now, collaborative filtering is a bit different. It looks at similarities between the users. It looks at similarities among the products. How it is done also we'll see. And of course, the third one is very logical. You combine 1 and 2, you get the 3, right? Now, let us see this. Just spend a minute, go through it. Are you able to see the screen? Otherwise, you can shift to the other side. Here, change are there. Just spend a minute on this. You will find it quite interesting. If you like an item, then you will also like a similar item, is the assumption. You can always question the assumption, right? Say, for example, you like comedy movies. Let's say you like comedy movies. So, what happens if I try to show you a horror movie, which is exactly the reverse, where at the end of the day, maybe at the end of the movie, everyone gets killed. But otherwise, you are more comfortable with the kind of maybe a movie which is highly kind of a comedy kind of movie like Rajendra Prasad, other things, okay? Now you see this, again interesting scenarios. There are different genres that are available, you will also see this. So if you like an item, then you will also like what is known as a similar item. Now the exact question here is, what is similarity? That we will answer now. As we go further, there are different ways of actually calculating this similarity. So, based on the similarity of the items being recommended, the recommendations work. We recommend the same kind of item like a movie recommendation or a song recommendation. Say, for example, you like Carnatic music, say, for example. How many of you listen to MS Subbulakshmi? Maybe in the morning, at least few people, right? Suppose if you don't listen to MS Subbulakshmi, I will play MS Subbulakshmi song or some kind of a bhajan or something. You may not like it, right? So, here my interest is in terms of knowing how to recommend you a similar item. Now, you look at this interesting scenario today when you are looking at this food also. Now, if you are ordering more in terms of, how many of you have these services of Swiggy and Zomato in your towns? Swiggy and Zomato is nothing but these are the service providers where on the app you order the food, one fellow will come and deliver the food. The only thing is it is a little bit costlier, but especially in a place like Hyderabad, instead of going into the traffic, eating and coming back, it is better you spend that 50 or 100 rupees extra and get the food home, right? So interesting thing is, when you are looking at this scenario, if you are talking about something like, let us say, biryani, if you are ordering often, you see more of biryani restaurants. Because that fellow already has recorded that you like biryani, right? Now, interesting thing is, one of the latest things that is happening for the past 2 or 3 years is late night orders. People are eating biryani at midnight, which probably maybe in your generation, I don't know, but at least in our generation, it was not there. So, one of them who is working in the Swiggy and Zomato, they told us that the orders keep on increasing, as the night keeps on approaching. That means they know 7:30, 8, 9 onwards the orders. There is a particular segment. Maybe not everyone, but there are people who actually order more during nights, that to midnights. They again know this. Okay, these fellows, okay, they order more of late night orders. So late night options are shown for them. So what is AI doing here? Studying my food habits. You see this. Whether you like it or not, most of the things that you use when you are using a digital device like a phone or a computer, your data definitely gets shared. Whether you like it or not, that's a different thing, right? Now, let us come to this scenario that is there. Any one of you please tell me what kind of a movie is this, the first one? Romantic, mass, comedy, family, emotional, right? See, good, because let me tell you, putting a movie in a bracket is also difficult. We'll see that later. Why? Other than content, if I am looking at the content now, you are saying it's a romantic one, it's a comedy, it's a family movie, it's a youthful movie, whatever it is. Now, the second one, comedy plus message, right? And of course, here, any message is there? No message, no? Now you see this, right? Another interesting scenario that is there. But this fellow and this fellow, are they the same? Right? Let us see. And no, look at this side also then. Okay. Because there is a purpose behind putting them. Otherwise, I could have put any picture, right? We'll also see. I will ask you one more question. If you like Rashmika's movies, should I go with Rashmika or should I go with the content? Both ways possible. Or if you like a particular director, should I go with the director? Multiple possibilities are there. That's why when you are looking at the content, on what basis you are actually classifying the movie is also interesting. Maybe my way of classifying is different from your way of classifying. Please understand that content based is a very good scenario, but these issues are there. So let us see. This is again AI generated for you people only, basically, because you will see later what actually we teach in the classes that you will not like. We'll go through that later. So what is one of the movie? Pushpa the Rise. Alavaikuntapuramlo Sarleru Nikevaru. So Pushpa is action. Allu Arjun is the actor, lead. Style is mass. Alavaikuntapuramlo action, drama. Drama is there, no? A lot of son getting into some other what you call Pune's or the worker's house, that fellow getting here, this fellow losing mommy and daddy, this fellow says, I will not allow you to meet your mommy and daddy. A lot of drama is there. Of course, logic is not there, that's a different thing, but a lot of drama is. For us, 2 hours, we need to get entertained, nothing, we are not looking at a message here, right? So again, who is the lead actor here? So what kind of a movie is this? Right, very clearly. Here, no doubt about commercial, it is mass commercial, right? Now, you please look at Sarler Nikavaru, action. Of course, Mahesh Babu, of course, commercial. Now, what are the pattern that we are seeing here? Action movies are there, commercial entertainers are there, star hero based. In fact, if you look at this particular specific example, in all these cases, the lead fellow is a star in their own way. Of course, I will not get into who is a star and not a star, but in their own way, they have that cult status of being stars, right? Now, let us look at this. When you are looking at the scenarios, a movie can be considered as a comedy movie, action, sci-fi, that is scientific fiction, adventure, fantasy. Like fantasy is like a Jagadeka Birudat Lokasundara. Have you seen? So Sridevi comes from the heaven. This is fantasy, right? Right? Yeah, anything you can take, right? Thriller, right? Some fellow at the night keeps on killing someone. At the end of the movie, you find that it is a heroine who is killing everyone, right? Now, musical, right? So, for example, a movie, if you look at our generation, we used to have movies like Shankarabharana, completely classical music one, right? Maybe people who love that might go for it. Similarly, you can have a drama-oriented one. Just now we have seen, there is a romantic movie. In fact, we have also seen, then there is a horror, animation, Western, whatever it is. I have just taken it so that you will understand basically what is the kind of genre that we are talking about. Now, how AI thinks, the explanation is that It looks in terms of the genre, the hero or heroine, director, music style, and then again you see keywords, mass, village, army, family. So if the student watches mostly action, star hero films, commercial entertainers, then I'll say that, okay, this person prefers action commercial Telugu films. You're making out a pattern. You're making out a pattern. You see, in machine learning, it is all about your ability to find out the patterns from the data, right? Especially when you're talking about unsupervised learning, it is all about making the patterns. Now, please look at the other three movies. So, which is this one? Rangastalam. This one? This one? Of course, here you have a surprise, of course. Now, let us see this. If this is the scenario, possibly, please look at this. The system may recommend Rangastalam, Sarkaru Varpata, Akanda because these share similar content features. So, if you look at this action, is there a strong hero in all these three? Is a hero-oriented movie? No, all these are hero-oriented ones. Okay. Then commercial format, yes, nothing is an art movie there. There is no art movie there. Everything is a commercial one. So, if you look at this scenario, just it is the matching that you need to do. If Pushpa is tagged as, this tagging is where the human being does the tagging. The human, like we said, these are apples, these are oranges, these are bananas. Now, for movies also, you say that what are the tags that are given for Pushpa? Action, crime, village, mass hero. Rangastalam, action, village, drama, mass hero. Look at the kind of similarity that gets into this. If you like, say for example, action, crime, village and mass hero, now you see very clearly it is there. So similarly, you can also look at high similarity is there, then go for recommendation, right? More matching tags are there, higher recommendation chance is there. So the whole idea is in terms of how you are going to add those tags, right? You need to classify the movie into different kinds of scenarios that are there, whatever the genres or whatever the, whether it is music dominated or it is action dominated, the categories that are there. So this is how basically you're talking about the content-based filtering. Now let me just tell you, the drawback about this content-based filtering is that, is there a uniform way of actually dividing these movies into categories? If someone asks me to categorize, I will categorize in one direction. If someone asks you to categorize, for you the movie is like this. You say that it is a romantic comedy. I'll say that there is no romance in this, only comedy is there. So what happens is tagging very much is not done by the AI, but then based on the tagging, the AI keeps on going with recommendation. So that's a basic drawback related to the content-based one. You see this, everything is based on the content, right? You are looking at the content and then you are going with this. Now, the actual calculations come here. You come across something which is termed as collaborative filtering, right? Now you see this. This goes with a little bit of a logic. If a person A likes 1, 2, 3, please see this. What is A liking? 1, 2, 3. A likes 1, 2, 3. What does B like? 2, 3, 4. See this very clearly. Total out of 3 here and 3 here. How many common are there? 2. So if I look at out of 3, the commonality is 2 by 3. 2 by 3. So it is around how much? 66%, right? So it is around 66%. So what I say is, can I recommend this 4th movie to this fellow and 1st movie to this fellow? Is at the very simplistic level the kind of argument that we are making. Again, the question is in terms of how do you actually measure this similarity? Now, this algorithm is entirely based on the past behavior. So I should know what are the movies you have watched. Sometimes if you have already watched the movies and also you have given the ratings, just watching a movie itself may not be an indication that you like the movie. One way is if you don't have the ratings, I need to go with your watching. Suppose if ratings are available, for a particular movie you have rated 5, for a particular movie you have rated 1, for a particular movie you have rated 4. The other fellow also rates the movies. Which are the movies where your commonality in the rating is there, I can see. That means you also highly rated it, that fellow also highly rated it. Then I say that, okay, probably these two users are similar because they have lots of similarity in the way they have rated the movies, right? So if you look at again this algorithm is entirely based on the past behavior, not on the context. Earlier is context. Here, I don't know whether the movie is a comedy movie, whether it is a horror movie, or whether it is some kind of a drama movie. I just know the ratings, that's it. I just know whether the person has watched the movie or not, that's it, right? So interesting perspective here is, this makes it one of the most commonly used algorithm as it is not dependent on any additional information. We just need ratings. A, B, C, D, what are the ratings they have given, or A, B, C, D, what are the movies they have watched. You need not know anything about the movie, that's it, right? So for instance, product recommendations by e-commerce player like Amazon and merchant recommendations by banks like American Express. Similarly, today you look at your Netflix, Amazon, Hotstar, AHA, everyone does this. Now, what are the two types of collaborative filterings that are there? I am making the concept very simple for you when you are looking at this. In fact, probably in the first class also I would have used the same picture. Who are similar here? There are two people there. There are two people there. What is the first fellow doing? Okay, he is riding a bicycle. Seems to be a sports bicycle again. The other fellow? Also more or less, because he also wore that helmet. He also has that sports dress. So these two are similar. Similarity is the same. Now this fellow is buying A, B, C. That fellow is buying only A, B. Now, can I recommend C to A, C to the first fellow? This is the kind of logic that you build around. But then the problem is, how many users you have on Amazon? Millions. How many products you have on Amazon? That is where again the issue related to using the computing power as well as using the right kind of algorithm comes into the picture. So user-user collaborative filtering, here we find look-alike. User-user is nothing but similarity you are trying to find between user and user. Based on that, you make the product recommendations. Are you clear with this? Okay. So the algorithm is very effective because it takes a lot of time and resources. It requires to compute every customer pair of information, which takes time. Now let us look at this. Suppose we have a scenario where there is a customer A and B. How many people I need to compare? A and B, that's it. A, B, C, A, B, B, C, A, C or C A. Luckily for us, C or A, C is the same. If I take A, B, C, D, you see it keeps on increasing, right? A, B, A, C, A, D, then B, C, B, D, C, D. Did I miss on anything? Okay. So what is happening here? For each one increase, the number of increases here are even going higher, right? So it is quite interesting again, if you would like to see how you are able to make this, how can I find this? So for big based platforms, this algorithm is hard to implement without a strong parallelizable system. That means to work on these combinations, you need to have a good hardware with you. That means you need to be able to deal with the big data. Now, we will just look at an interesting scenario. When we are looking at the previous scenario, we said that we are looking at similarities between whom? User. Now, please look at the next scenario. What is that we are talking about here? Item. Forget about the user. Now, you are looking at the products. Now, let us see this, quite interesting. Simple shopping example. Imagine you're on Amazon, you buy a wireless mouse, laptop bag. Now, Amazon recommends keyboard, laptop stand. Why? Because many people who bought wireless mouse also bought. So there is a similarity between wireless mouse and keyboard. So if you are buying wireless mouse, what is that I am suggesting you? If you are buying keyboard, what is that I am suggesting you? Got it. Earlier, you look at the person. Here you are looking at the item or the product, right? So Amazon generally says that, okay, people who bought this item also bought that item. This is what is known as item-item collaborative filtering, right? So you have seen two things now. One is a user-user collaborative filtering. The second one is item-item collaborative filtering, right? Now I'll just take you through a few scenarios where how to measure the similarity is the biggest scenario here. Now, so far what we said is, if you look at the left side scenario, when I'm talking about user similarity, you are saying that this A and C are similar. So whatever A is buying, you recommend that to C. Whatever C is buying, you recommend it to A. That's what you try to do here. Similarly, here when you are looking at the item-item kind of a scenario, you find that two items are similar. So fellow whoever is buying this gets recommendation of this. Fellow whoever is buying this gets the recommendation of this. So here it is a similarity between the person to person, that is basically the user to user. Here the similarity is between item to item. You see this, if you really look at the scenario, in both the cases the products are the same, the people are also the same. But then if you really look at how this algorithm is working, because if you look at the other scenarios that are there, the dotted lines basically that related to making the recommendations, on the left side it is based on the people, on the right side it is based on the products, right? Now let us look at how this is done. This involves a little bit of mathematics, but let's also make it easier, right? Okay, let me ask you a question. Did you sit in the same places on the day one? How did you started finding your friends? My assumption is that there is a k nearest neighbors algorithm that says that birds of same feather flock together, right? Generally, are you comfortable with a person who is similar to you or dissimilar with you? Because I say A, you say Z, that doesn't go, or sometimes may go, but generally speaking, you're more comfortable with the kind of people who are similar to you, right? So here, can I look at distance as a measure of similarity? Can I look at distance as a measure of similarity? So in this case, what happens is, if I have a scenario like this is point A and point B, simply speaking, how is the distance calculated here? X1, Y1 and X2, Y2. What is the formula for the Euclidean distance? Euclidean distance D is equal to square root under Y2 minus Y1 whole square plus X2 minus X1 whole square. This is one perspective. But Euclidean distance is always a straight line, right? So for example, from here, we have to go to your guest house. You can't fly in a straight line. I need to take the road, then I need to take the road. Now in this case, what is the distance that is traveled? You started at x1 and moved up to x2. x2 minus x1 is the distance. And after you reach here, from here to here, you moved here. So when you are looking at this distance is y2 minus y1. So my total distance is, in the second case, is x2 minus x1 plus y2 minus y1. This is known as a Manhattan distance. This is known as a Euclidean distance. Because here, the way of looking at the distance is how much you moved on the x-axis and how much you have moved on the y-axis. In this case, it is like a straight line. In straight line, you are going from one place to another place. So if you look at the various types of measuring similarities, as distance increases, what happens to the similarity? Decreases. First thing we realize, as distance decreases, maybe if I look at especially, I'll just make a few scenarios. People in this first row, that row, especially the second row, they're tightly packed. 4 people are tightly sitting together. Why? Any reason? No, if they want, empty chairs are there, but 4 people tightly packed together. I don't know. Similarly, I look at the last row. That's also interesting. Always they keep on checking phones and laptops. I don't know the reason, but always it happens. And one of them already took a break also, right? So the interesting scenario here is, when you're talking about similarity, you're going to calculate it as an anti-distance. A distance increasing, similarity decreasing. The reverse of distance is similarity. The higher the distance between the 2 objects, the more farther apart they are. On the other hand, the higher the similarity between 2 objects, the more closer together they are, right? If you get this concept, the next challenge is how to measure it, because we just said that distance is anti of similarity, right? From here, let us go to the next scenario where we look at a few measures of actually finding out this similarity. Just spend a minute on that. Just spend a minute on that. Don't be worried about if you can't get it. There are 3 basically measures basically here. One is the Jaccard similarity, the cosine similarity, and the third one is Pearson similarity. Jaccard similarity, cosine similarity, and Pearson similarity. If you look at the Jaccard similarity, it is based on the number of users who have rated item A and B divided by the number of users who have rated either A or B. We will see that what it means. A very simple example we will take. It is typically used when we don't have a numeric rating, but just a Boolean value like a product being bought or an ad being clicked. Now, what is this Boolean issue here? Now, if I look at a movie, either you have watched or not watched. There are only 2 cases. Either you have watched the movie or not watched. So, how many values can be taken? Only 2. Either it is yes or no, either it is 0 or 1, binary, more or less it is like binary. So, what happens here is, if I have ratings, it is okay. If I don't have ratings, I will see consistently how many people have watched the same movie, how many people avoided which movies, is there a pattern between them? That's how I go with it. That is what is known as a Jaccard similarity. Now, the second one is even more interesting, as well as a little bit complex in terms of the calculation, what is known as cosine similarity. So, when you are talking about cosine similarity, you find something interesting here. I will just give you a small scenario, you have to answer this. Person A is going in this direction, person B is going in this direction. When do they meet? Why? Okay, maybe if at all their starting point is 0, 0, is the origin, right? But they are not, because I started this direction, you started this direction. Can someone guess and tell me what is the angle here? 90 degrees. Okay. Now, compared to this, let us say this is A, just to avoid the confusion, I will write A there, A and B. I will say that there is a person C who is going like this. There is a person who is going like this. Are A and C similar or B and C similar? How did you give this answer? Direction. You look at the direction. Okay. More or less they seem to be going in the same direction. That's all. Similarly, I look at another scenario where I look at a D that is going here. D that is going. Now, is AD similar or BD similar? AD similar. That means what you have to find here is, if you have to put it in a different dimension, okay. Now, in this case, your directions, they don't match. You're going in one, that's 90 degrees. As I keep on moving in this direction, or as I keep on moving in this direction, what is happening? Either this is coming down or this is going up. So, what is happening here is you are having a scenario where now this is changing. That means from 90 degrees, the angle is getting decreased. Earlier it was 90 degrees. From this 90 degrees, what happened? Now it is maybe 30 degrees or 40 degrees. And then they keep on moving in such a direction that finally both are in the same direction. So for example, if I completely overlap here, see, think of it like your clock, right? So in the clock, when you have the hands, let's say this hand is entirely coming here. So what happens here? Both of them are exactly on the same. That means, what is the direction of both of them? Same. Therefore, I can say that they are exactly similar in terms of direction. What is this direction? We will understand again. Are we clear with this? So what I'm doing here, I am looking at what is known as cosine similarity. Similarity is the cosine of the angle between the two vectors. Say for example, if you are looking at, again, don't be worried about how this calculation is done, but just get the idea, because if you have got the idea, only thing is, I try to find a value for this. If I look at my high school mathematics, cos theta, that is cos 90 is equal to 1, sorry, 0, 0, 0. Cos 90 is equal to 0. That means, if 90 degrees means, there is no similarity. Cos 0 is 1. When does this cos become 0? If it completely comes here, or if it completely goes there, what is the angle between these two, A and B? 0. Say for example, you can also look at another interesting scenario. I go exactly in this direction. That is also possible. You are going in that direction, I am going in this direction. Now in this case, what happens is cos of 180 degrees, 90 plus here 90 and here 90. So total is like 180 degrees. 180 degrees equal to -1. These fellows even worse than the 0, because this fellow goes in this direction, that fellow goes in that direction, right? So quite interestingly, this happens to be one of the measure. Similarities, we will see that, don't be worried as to how it is done. Similarity is the cosine of the angle between the two vectors of the item vectors of A and B. Why you call it as a vector is because you are looking at a direction. Not only that you are looking at the value of it, but you are also looking at something called as a direction. When we take an example, it becomes easy for you. And finally, we have something called as Pearson similarity. Okay. Where did you come across this term called as Pearson earlier? Correlation, right? So when you are looking at the correlation, what is correlation all about? Okay, relationship and the direction also, because two of the things can be correlated exactly in the negative side also, as one is increasing, the other is decreasing also. So these three are basically the measures which will basically determine as to how you are going to find the similarities. Okay, spend a minute. కనపడుతుందా? So if you are done, okay, take your time. Okay, reading is over. Now let us try to put it in a different format. If you can basically make out the meaning, your Jacquard similarity is going to be very easy for you. Now if you remember your high school, we had this what is known as set theory, A, B. What is this? A intersection B. A union B is A and B together, okay? So if I look at A intersection B by A union B minus, should I do something? B or A, why? Because you are avoiding double counting, we'll do that. Now don't be worried about. How much is common between A and B? This portion. Suppose In this case, tell me what is common between A and B? In which case the similarity is more? Second case. Out of the total, how much is similar is what you are basically trying to do. Now, we'll take a small example where it becomes easy for you to look at the concept. You can just work out. Just take this. Exactly, you need take this. You can work on this. If you can take this, you can start working on this. Take two circles, and then you start looking at keeping exactly the same number of dots, keeping exactly the same number of dots on either side. So, how many dots are there in S? Okay, 1, 2, 3, 4, 5, but 3 are in the intersection. And how many are there in T? 6, out of which 3 are there in the intersection, right? So, now shall we look at the formula? A intersection B by A plus B minus A intersection B. A intersection B by A plus B minus A intersection B. Let's see this. How much is A intersection B? How many are there? 3 are there. 3 divided by, if you separately count A, how many are there? 1, 2, 3, 4, 5, entirely 5. If you look at B, how many are there? 6 are there. How much is again the intersection? 3 is equal to 3 divided by, now you see this, 11 minus 3. That means 6, 5, 11 minus 8, 3 is 8, no? 8. 3 by 8 is basically the similarity that you are looking at. Now, without this formula, please tell me. Without this formula, just look at that. You don't need this formula. To be very frank, for a picture like that, you don't need this formula. What is the intersection? How many are there? Total, how many are there? Count. 1, 2, 3, 4, 5, 6, and 8. That's it. You don't require the formula. If you basically see this, I'll tell you, this is from a book called as Mining Massive Data Sets, written by, I think, one of the Stanford professors. What they have done is there's a classroom teaching. They made it in a book and they kept it for free on the web. The beauty of this example is that I was not looking at a formula, because the way they have given it is so simple that what is my intersection B? 3. Total, how many are there? 1, 2, 3, 4, 5, 6, and 8. 3 by 8. Why I need a formula here? Because if the complexity increases, I can't keep on counting. So, why I need to remove this A intersection B here? To avoid double counting. Because you are counting these 3 when you are counting this, you are counting these 3 when you are counting this. Only in one case you need to count, right? Are we clear with this? Now, your 3 by 8 is the similarity. Now, what is Jacquard's distance? Distance is 1 minus Jacquard's similarity, 1 minus 3 by 8, which is equal to 8 minus 3 by 8, which is equal to 5 by 8. Distance is more or less? More or less. If you really see, relatively speaking, right? If you can compare, then you can come. Are we clear with this? Okay, now please see this. An important class of problems that Jacquard similarity addresses well is that of finding textually similar documents in a large corpus, such as the web or a collection of the news articles. Interesting case is, how do you find out similar documents? How many words are there in this document? How many words are in other document? Combinedly, how many overlapping are there, the same words? More the words are coming frequently, the similarity among the documents is more. But again, the thing is, when it comes to the language, you can have synonyms also. It may not be exactly the same. For the same word, you could be using a synonym also. So they will consider that also. Towards the end, if time permits, I will take you through that. So please look at this when we are talking about the scenario. What has happened here? J of A, B, A intersection B by A union B, that is nothing but A intersection B by A plus B minus A intersection B. Are we clear with this? Now just take one more interesting scenario. S1 is equal to S1 is equal to 1, 2, 3, 4, 5. S1 is equal to 1, 2, 3, 4, 5. Okay. S2 is equal to 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. S1 is equal to 1, 2, 3, 4, 5. S2 is equal to 4, 5, 6, 7, 8, 9, 10. Say for example, this fellow has seen movies 1, 2, 3, 4, 5. This fellow has seen the movies 4, 5, 6, 7, 8, 9, 10. What is the similarity now? That's it. So you see this, how many are common here? 4 and 5. 2 are common out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, what is your Jacquard index? 2 by 10, no? 10. Total 10, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are common, right? So 2 by 10 point. So what is the Jacquard distance? So that comes to 0.8. Now say for example, you need not work out this. You look at this, the second set 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. Just check this. How many are similar here? This, no, 4 and 5, no? Only 4 and 5. But then how many total are there? 1, 2, 3, 4, 5, 6, 7, 8 out of 8. So from 0.2, the index increased to the Jacquard distance from 0.8, it got decreased to. You see, that's how basically you find how the similarity is moving. Now, in the second case, similarity has increased a little bit, right? Are we clear with the concept? Okay. You don't worry about this. For a movie, how it is done, that is your question right now, right? So please look at what is given there. We will discuss. Now, your question is, sir, you said that we are going to do it for movie recommendations. How are you going to do this? Please spend a minute on this. So HP1 is Harry Potter 1, Harry Potter 2, Harry Potter 3. TW is Twilight, SW1 is Star Wars 1, SW2 is Star Wars 2, SW3 is Star Wars 3, right? These are the movies. And say for example, the people who have seen the movies are ABCD. ABCD are the 4 people who have seen the movies. So A has seen which of the movies? Twilight and, okay. Now let us say, what are the movies B has seen? What is commonality between A and B according to Jacquard? Only 1 out of total how many movies? 5. You are double counting Harry Potter 1 if it is 6. So just you can look at this. Only thing is your algorithm comes because there will be thousands of people who will be watching. They will be giving it. And you will be having hundreds of movies that are there. Are we getting this? Just by looking, this is a logic. Only thing is, the algorithm is trained and then they give this formula into the program and then release it. It keeps on doing it and accordingly it keeps on looking at to whom it has to recommend, to whom it should not recommend. Say for example, what is the similarity between A and D? That's it. Just look at this. There is no similarity because whatever movies that fellow has seen, this fellow has not seen. Whatever movies this fellow has seen, that fellow has not seen. Probably there is no similarity because movies, it's your choice, no? Right? Are we clear with this? But Jacquard similarity comes with its own limitations. We'll discuss later. Don't think that that's the only thing that is there. It comes with its own limitations. Later we'll see. Now let us look at the cosine similarity. Since I already explained you, it should become very easy for you now. Please look at the angle. There's 2 red lines are there, no? So they are basically the vectors, and then when you are looking at the angle, you see very clearly, as these arrows come closer, the angle is reducing. As the arrows are going away, the angle is increasing. As the angle is increasing, similarity is decreasing. Now this is where you can see, when you are talking about cosine similarity, there is an interesting scenario. You are talking only about the direction. You are not talking about the magnitude. Just please follow this very carefully. When you are talking about cosine similarity, you are talking about the direction. You are not talking about the magnitude. What it means, I will tell you small. Suppose, tell me your favorite topic on which you would like to write an article. Any favorite topic. of, okay, customer perception of fast moving goods. Sir has written a 100-page article on that. On the same topic, you wrote a 10-page article. He has written 100 pages. You have written? He wrote about what? What did you write about? Direction is the same. Magnitude is, that is where it comes. Are you getting me now? When you're talking about the cosine similarity, basically what you're talking about is, what is the direction in which the discussion is going on? Or what is the scenario you're looking at? You're not interested at this point of time in terms of the magnitude. You're only looking at the direction. That means, okay, they're dealing with the same topic. Say, for example, I'll look at one thing. He has written 100 pages. He also has written 100 pages. And Jacquard similarity came to be 90%. Not cosine, Jacquard similarity I'm talking. What does it mean? Jacquard similarity is 90% means 90% of his words and 90% of his words also came from the same. They are matching because both of them copied from some other fellow. Are you getting me? I'll tell you. I'll give a statement. What is the need for training teachers on AI? Now, first speaker comes and says that the AI, now the time has come for AI to move from the laboratories into the real world. Second fellow also says the same thing. Third fellow in the vote of thanks also says the same thing. All three have taken from ChatGPT. See this, carefully observe, you find immediately patterns that are there. If you're actually calculating, you'll find it. That's what you see. It is quite interesting. Whenever you are looking at finding out similarities, are you looking at the same topic? Oh, I am looking at the same topic means the direction is the same. But if I am looking at the content in terms of words, say for example, when I am talking about plagiarism, today you have softwares that are available. Say for example, Turnitin is there. It will basically detect the plagiarism. If both of you can work on consumer behavior, nothing wrong. But your words, her words, his words, my words, all are coming in the same, something wrong is. Because it will say, I'll go for every 10 words, they're called as shingles. If the time permits, I'll show you. It keeps on comparing. Even the sequence of words is also the same. Technically, it is not possible, right? Are we getting this, right? Okay. This I have already given you, need not worry. Cos 0 is 1, cos 90 is 0. 180. Smaller the angle, the more similar. As the angle increases, similarity decreases. Okay, you can just see this, the same scenario, not required. Here we have already done this. Now this is where actually we have taken it from your open source, which is Wikipedia. And the Wikipedia. So when you are talking about the articles that are available on the Wikipedia, now you see this. The first page is on Sachin Tendulkar. You have gone to Wikipedia page of Sachin Tendulkar. The second page is Wikipedia page on Dhoni. The third one is nothing but some of the Dhoni content you have taken and put it. A subset of Dhoni. Can you see this very clearly? When you're talking about the scenarios, you find quite interesting ways of looking at this. If you see Sachin Tendulkar, that is one. If you look at Mahendra Singh Dhoni, that is one. Can you see a small border in red of Mahendra Singh Dhoni? That is kept as a third document. That is kept basically as a third document. So what we'll see here is, if you look at this, one simple way of looking at this, in Sachin Tendulkar's page, how many times Dhoni has come? Cricket has come? Sachin has come? In the Dhoni page, how many times Dhoni has come? Cricket has come? Sachin has come? In the small section of Dhoni, subsection of Dhoni, Dhoni is coming, cricket is coming. Now can I start looking in terms of looking at the similarities between Dhoni, Sachin and cricket? Each of the scenarios, you see, the same repetition is not there, but you can really make out in terms of finding out how the similarities are basically going to make a change in terms of finding out whether it is a content that is copied or whether it is related to the same topic. Say for example, if you look at these two scenarios, you see this, cricket is coming 50 times here, cricket is coming 100 times here. But very clearly, when you look at Sachin is coming, Dhoni is coming, but whereas here Dhoni is coming, Sachin is coming, the difference is there, right? Okay. Now, if this is expressed as a vector, you see this. One way of visualizing again, when you're talking about this, what I basically do is, I look at each of these documents, and say, how many words I have taken here, say in this case, how many words we have taken? Cricket, Dhoni and Sachin. You see this, 3 words we have taken. So I create 3 dimensions. If you look at this, your x-axis is Dhoni, your y-axis is cricket, and your z-axis basically is Sachin. Can you see this? This is the Sachin, this is the cricket, and this is the Dhoni axis. Now, what are you looking at is, you are looking at each of these scenarios and saying that, okay, what is happening here? Whenever I am trying to look at these documents, what is happening here? Now, if I look at, you see, dog Dhoni is there. From the dog Dhoni, what is that I have done is, from the document of Dhoni, I have taken a portion of it and created mini Dhoni, right? Now, what should be the similarity between these two? Higher. I copied this and kept here. If I had copied entirely, both of them will fall on the same thing, right? So here, if you look at this angle, what happened now with respect to the angle between Dhoni small and Dhoni big? This green and red, what is the angle? Very less, very less. That too because you have not taken some of the portion. But let us say, if I look at dog Dhoni versus dog Sachin, dog Sachin is creating more impact on the Sachin word, whereas your dog Dhoni is creating more impact on this. So what is happening here is, the distance between these two, if you need to see, this is the Euclidean distance, but at the same time, if you are talking about the cosine angle, the angle is also increasing, So if you see this, of course, we are looking only at a very small portion. If you look at text analytics, natural language processing, very sound mathematical principles are there, based on which they are able to catch it. You see this, you will get a very interesting perspective. Both of us have written on the same topic. In the plagiarism, is it allowed? I have a different perspective, you have a different perspective. But then, should the words match beyond a particular? That's where they say. Maybe they accidentally, maybe 10%, 15% is fine. But if 80% is matching, means some problem is there. Can you go to the next scenario? If you want, just spend a minute here. Just spend a minute. Done with the reading? Now, what are the coordinates of the first point? 3 and 4. What are the coordinates of the second point? 30, 40. So, if I look at this as x-axis, and if I can take this as, let us say, y-axis, in the first scenario, it is 3 and 4. It is 3 here, right, and 4 here. So, if I look at this, right, this is where they are meeting. This is my vector. This is my vector. Let's say this is my vector. This is vector 3, 4. But if I look at 30 and 40, let's say somewhere here it is 30 and somewhere here it is 40. This 30 and 40 will be like this, where I am talking about 30, 40. That means if you look at these two vectors, what is the angle? Same. But magnitude, is it the same? It is different. That is the whole idea. Same thing can be done, especially in the context of what I call movies also. If you want, you can spend a minute on this. But the only thing is, there is a way of actually finding out the cos theta. If you would like to see, you can just see this. If you are looking at cos theta, what we do is, if A is like this and B is like this, your top one, A dot B is this into this plus this into this, divided by square root under 0 square plus 3 square plus square root under 4 square plus 0 square. But what is happening here is when I am looking at 0, 3 and 4, what is 0 into 4 plus 0 into 3? Your numerator is, therefore your cos theta is, when is cos theta 0? 90 degrees. Now, we will just plot this 0 and 3, right? We will look at the same thing. What is 0 and 3? 0 on the x-axis, 3 on the y-axis. The next one is 4 and 0, right? So, when I am talking about 4 and 0, 4 is on the 4 and 0, no? Yeah. So, 4 is here. So, what is happening? This vector is going here, this vector is going here. Are you getting this? So, when you get into it, actually it becomes quite interesting as to how you try to keep on looking at the similarities. Using the same again, you can start doing it for this, right? Not required, we have already done this, okay? Now, you can see this if you are looking at a scenario that is there. Movie A 541, movie B also 541. Please tell me. Movie A, please see this. Movie A, if you see this, how many users are there? 541. Movie B, so what is happening is, interestingly, cosine similarity is, that means that the movies are similar. Now, you see this, the same scenario. Movie X ratings 555, movie Y ratings 222. Please see this. Movie X ratings 555, movie Y ratings 222. Even though the numbers are different, the pattern is the same. So, what happens to the cosine similarity? 1. So, what happens here is, maybe I give less marks every time, you give high marks every time, that differences also will be taken care. There is a person, say for example, for whatever I am rating 5, you very strictly rate it only as 3. So, consistently you gave 3, 3, 3 to a movie, I gave 5, 5, 5 to a movie, still it is similarity in terms of cosine similarity. But if you look at only this 5 and 2, then there is a difference. So, what is happening here is, when you are talking about the scenario, cosine similarity is 1 because the direction is the same, it ignores the scale, focuses on the pattern. Clear with this? Okay. Now, next take down user collaborative filtering. User collaborative filtering. So far, we have seen the similarities among the movies, among the documents. Now, we will look at among the, user. So far, what you have seen is item. Now, this is like a user. Okay, just see this. Don't be worried about the formulas and other things. You just look at the ratings that are given. How many movies are there? X1, X2, X3, X4, X5, right? How many users are there? 3 users are there. Now, you see this. What he does first is, he takes the average rating. What is the average rating given for all the movies by the fellow A? 4 plus 1, 5, 5 plus 4, 9, divided by how many movies? 1, 2, 3. He watched only 3, right? He watched only 3, right? So, 4 to the 8 plus 1, 9 by 3, which is 3. Similarly, you look at this is also 3. Similarly, you look at this is also 3. But because their mean rating is same, they are not similar. So, what we will basically do is, we will use this the similarity formula, which is more or less as your Pearson correlation coefficient, and then we will find out what is the correlation coefficient between A and C versus what is the correlation coefficient between B and C. Interestingly, what you find is that, especially if you look at A and C kind of a scenario, you find one value. Similarly, when you are looking at B and C, you find another value, right? So, this is where actually you try to look at how users can be rated. Do you have any information about the movies here? No information, only ratings. You don't require also. That is one perspective. But then we have an interesting scenario. Just any one of you please tell me, what is this? I will ask you a question. Are you done with the reading? Then I will ask you a question. Okay, shall we? Now, let us look at a scenario like this. Pardon? It will be entire data. It will be entire data. If you want, you can take a sample. but technically they have entire data. The big data is a scenario where no longer you are looking at samples because you have almost all the data with you. If you want, still you can take a sample. That possibility is there. Now let us look at this scenario, quite interesting. You have to answer me a question. How many movies might be there, the total number of movies across the world? Give some figure. I don't know. First thing is I don't know the answer. Some rough number. 10 lakh movies. Good. What is the population of Hyderabad? Let's say 1 crore. 1 crore. What is the population of India? 140. What is? Are the users more or the movies more? So user-user collaboration means it becomes very difficult in terms of computing. More than the items, you will have the users. Look at every case. If you look at items, they are there, huge number. But compared to items, the customers are even more higher. So that is the issue that is there. This algorithm is time consuming as it involves calculating similarity for each user and calculating prediction for each similarity score. One way of handling this problem is to select only a few users instead of all making the predictions. Instead of making predictions for all similarity values, we choose only a few similarity values. This is the inherent what you call drawback of this algorithm. Now, what could be the answer? What could be the answer now? Earlier you were talking about user. User is going to be computationally it can be done, but computationally very hard. So can I go with item-item collaborative filtering? That is quite interesting, where you are no longer looking at only the people, but rather you are looking at the items. Only thing is, when you are talking about the similarities here, you see earlier you see this. In this, you calculate the mean user rating. How did you calculate the mean user rating in the user? 4 plus 1, 5, 5, 4, 9 by 3, 3, like that for each of the user rating. But here, we exactly go the reverse way. What are we doing here? You look at item x1. What is the mean score of item? 4 plus 2, right? 6 divided by 2 is how much? 3. x2, 4 plus 1 plus 1, 6 divided by 3, which is 2. x3, 4 plus 2, 6 by 2, that is 3. So you go across by the items rather than the users. Are we getting right? So what happens? This algorithm works similar to the user-user collaborative filtering with just a little bit of change. Instead of taking the weighted sum of ratings of user neighbors, we take the weighted sum of ratings of the item neighbors. So again, the calculation is going to differ here. If you see, we take the mean values based on each of the movie. That is the item that is there. It could be a movie or an item. Since it becomes a little bit interesting if we take movies into consideration, we have gone for this. So for example, if you can look at this scenario as well as this scenario, you can see as to how the similarities keep on changing among the movies. The only thing is, in the earlier case, you found the similarity between the users. In this case, you are finding similarities between the items. Are you clear with this? The same Pearson formula is being used here. Now, there is an interesting question. What if you are a new person, there is no history available? Earlier, my ratings, your ratings are similar, the recommendations meet. You have just entered, or a movie just came. This is what is known as the problem of a cold start, right? So when you are looking at a cold start, that means a visitor could be new or a product also could be new. So visitor cold start means that a new user is introduced into the data set. There is no history of the user. What do? First, give them the most popular ones. As he starts watching, his history gets built, then start using it. You see this, what you are doing is, one basic approach could be apply a popularity based strategy, recommend the most popular products. So you know which are the most popular products. See, I don't know about anything about you. So what I suggest, the highest rated movies, the most popular ones is what I am going to do it. The same scenario. When you are talking about the product cold start, right? Product is new product is launched, you don't have any previous history. More the interaction a product receives, the easier it is for our model to recommend. We can make use of content-based filtering to solve this problem. In this case, what they are doing is this, content-based collaborative filtering. What they are doing is this product similar to some of the products based on the content, and then go for it. Again, once the history of this particular movie or the item gets kept on building, you go for the next one. So the next one related to this is chatbot. These are all relatively easy. We need not spend so much of time on this. I think all of you would have at least interacted with one chatbot. You go to a website or use your apps. These days what is happening is, even for making a complaint, there is no person. Directly you will be typing in and that particular chatbot will be interacting with you. So it can be used for order tracking, refund account issues, frequently asked questions, and chatbot is available 24/7, unlike a person, right? Chatbot is available 24/7. What are the benefits? Instant reply, no waiting, as well as essentially why companies are going for this cost saving. Okay, so this is a small example that is there. If you look at this scenario, this particular part again, I tried it in Telugu actually to give it, but it did not come out very clearly. We are talking about certain schemes and savings. It started giving certain information that is there. So this is one example where in banking you could be using. But then the interesting perspective here is when you're looking at the classification of the chatbots, chatbots can be classified as two types. One is rule based, second one is AI based. This you can note down. Chatbots classification, rule based chatbots and AI based chatbots. Rule based chatbots versus any guesses what could be the difference?
Based on decisions based on the existing information.
Not standard terms. Based on what you are asking, if this is the term that is coming, give this answer. That's why you see in some cases the chatbot, you ask anything, it gives the same answer. Beyond that, it can't do anything. It can't process the language. But whereas when you're talking about the AI based on, it understands the natural language, learns from interaction. So it gives a better experience. That's exactly where again you can start looking at how these banks are using that. Now you see this, say for example, if I'm looking at a rule based one, check balance, view transactions, loan inquiry. Beyond this you ask anything, it says choose something from the menu, that's it. Beyond menu it may not be able to go, right? So you're getting things like this, right? Now interesting case is like if you're not taking 1, 2, 3 and you're asking something like, I am worried about my savings. What does the chatbot do? Because it only understands predefined commands. So, pardon? No. Now this AI chatbots are coming based on what is known as natural language processing. Natural language processing is a very what you call in-depth subject where the language specialists as well as the computer science people, they create, in fact, later also you will see, they create language in such a manner that the computer understands the language from a computational perspective. The computer starts understanding the language from a computational perspective. There are methods for doing it. Both these language people as well as the computer scientists, they came together. That's why if you see today, for most of the applications, for English, you already have the developed applications. But if you look at regional languages, slowly people are developing because there was no interface between the language specialist as well as the computer specialist. Now, if you are talking about the chatbot, let's say we are looking at AI plus NLP. Now, we are using machine learning. We are trying to understand the intent. We are looking at the data learning. The other day we said that the ChatGPT, if you see, slowly now they are looking at the new models where NLP is being introduced. Maybe you are trying to look at understanding the language, trying to understand the intent, and then going for it. So, user types a message. Now, this NLP processing is occurring, identifying the intent, getting the correct answer, and learning from the interaction. So, if you really look at some of the scenarios that are there, you can see this. There are two scenarios that are given here. You are talking about where is my biryani order tracking, ID, fetching the status. Your order will arrive in 12 minutes, whatever is there. Now, delivery is too late. It is understanding it as a complaint. Maybe it is looking at the frustration from the customer. Now, what is happening at the last level? It has to escalate. Beyond that, it cannot go, right? Similarly, here you can see this. If you are going with your AHA, suggest me some Telugu comedy movies. So language is Telugu. What is the genre? Okay, again rule based, because you said that I need this and this. Now I need to give a combination of this, right? So rule based works on fixed rules, menu driven, cannot learn, low cost. The same exactly reverse happens in the A based, it understands the language, conversation driven, learns from the data, higher cost as well as highly flexible. Now beyond the boards, now it is your virtual assistant. You can speak to your phone, you can speak to a device, right? The other day we were talking about smart devices. So what is happening here? It is more advanced than a chatbot. So you can see this, your Amazon Alexa, your Google Assistant, you can start dictating things, it keeps on interacting with you. You can play music, order things, control smart devices, answer the questions, right? So chatbot is website based, virtual assistant is on the device, it is device based. So which can do more amount of tasking, right? So that is quite interesting again. So now comes the sentiment analysis. If you see, this is again related to the language. By looking at the language, can you understand the sentiment? Now machine has to do it. That is quite interesting. Because the problem is, if you look in terms of the data that is generated today, you see anything goes wrong, people will put it on X. And then comments are there, feedback forms are there, right? Multiple scenarios are there. So at the end of the day, for the company it is very interesting to find out whether a review is positive, negative or neutral. Very much interested in terms of looking into this. And then when you look at review mining, what are the reviews are there? From the reviews, you get the insights. So say for example, I go through 10,000 reviews of my product and I will find out which are the common problems. What are the strengths and weaknesses of the products? What do the customers like about the product? What do the customers dislike about the product? I'll just give you a small example just to tell you about this. Any one of you ordered books on Amazon, right? Generally when you order a book, you go with a book which you would like to read on, right? But sometimes for a good book, which is a bestseller, you also start looking at ratings going very low. What could be the reason? Further, think about it. You're ordering a physical copy of the book. Maybe the book is damaged, or it's a Xerox book. These days what is happening is, rather than from a publisher, a pirated version, right? So it is just Xeroxed and then sent to you as a book, or the paper quality is bad. Now what is happening here, when you're trying to look at these scenarios, we are looking at what the customer likes, what the customer dislikes, how to improve. So that's how today, if you look at, you can buy books in the electronic format, Kindle books. So Kindle book doesn't get old, interesting. But the only thing is, you need not have the Kindle device also. You need to just download the software. Kindle e-reader is what you need to go for, and then start using it. So these are again some of the examples that are there. So if you start really looking at what is this sentiment analysis, you will have a dictionary that is made where positive things and negative things are listed. Can you see this? Amazing, excellent, fast, good, bad, late, poor, worst. Can you see this? So one of the simplest ways is like, if you are looking at a scenario, camera quality is good, but the battery life is poor. Positive word is good, negative word is poor. A simple scenario is like one positive and one negative. What do you say? Cancel each other. At the simplistic level, it goes beyond that, right? Similarly, if you look at another scenario, food delivery, food is tasty, but delivery is slow. Packaging is bad, service is excellent. So most complaints are about the delivery, most praise is about the taste. So business action is improve the delivery speed. This is from the review mining. Similarly, you can look at hotel reviews and other things where everything today is done on the internet. So positive, negative or neutral is what we are trying to see this. Like we say, a mobile phone review is there, battery negative, camera positive, price is positive. Now you can say, really speaking, there is one negative attribute, but how many positive attributes are there? Two positive attributes are there. As you go further, when you're talking about NLP tries to understand the human language. It interprets the meaning, analyzes the text or speech and responds intelligently. This is where the difference comes. It just doesn't look at your number of positive words or number of negative words. It goes beyond that in terms of understanding the meaning. So what happens is, NLP allows machines to read, understand, and talk like humans. That's the difference. When you're talking about a AI-powered chatbot or any AI-powered device that is there, rather than going simply with the rule-based ones, here it tries to basically understand and then it is able to read and talk like human beings. So what is that we are talking about here? Humans understand language naturally. Computers do not understand the words directly. So what happens here? NLP converts language into numbers and patterns. From that, the computer derives the meaning, right? So how many topics did we cover today? To start with, recommendation engines, right? Collaborative filtering. That collaborative filtering is nothing but about the recommendations. Within that, content based, then user based, and then item based. Then we have gone with chatbots. Then we have gone with smart devices that are there. Then looking at final sentiment analysis. If you have any questions, you have another couple of minutes. For cross-selling, upselling as a part of why you are doing this. When you are talking about recommendation, correct. When you are talking about recommendation engines, why you are doing is possibility of a cross-selling and upselling is there. Perfect. Okay. If you have any questions, fine. Otherwise, you can take your break. Okay. Thank you.
AI, artificial intelligence, right? So as a part of that, we are going to discuss today uh, one topic called, the inventory optimization and demand forecasting. Right, I'm sure you are all management and commerce faculty members, right? So you know all these things. What is inventory management? What is demand forecasting, right? And then how do we do it using these AI technologies? Okay, so here this session is going to be driven through variety of the examples in the real time how it is happening, especially in the area of operations or the supply chain network. I'm sure everyone is going to get connect with the discussions. This is what I have designed this session. And also we'll try to discuss the ethical issues related to the use of artificial intelligence, because nowadays everything has become open access, right? So it is up to us to use the information more uh, meaningfully and mindfully, so that we can avoid all sort of the things. This is what the agenda set for this today's class. This is how we are going to discuss. Right now, look at uh, in this class. Basically, I am going to mostly focus on how this inventory and then demand forecasting is going to be integrated in generating the output actually, right? So here we are not going to work, I'm not going to use any kind of software now here, because you are going to have some kind of hands-on experience labs. It's only a theory kind of the session I'm going to deliver today, where in which you'll be sensitized to understand the importance of inventory and then demand forecasting, right? So now let's go ahead discussing what and how this is. See here, now I just wanted to put one question to all of you. See here, this is all about demand forecasting and then inventory management, right? So we are all teachers. Okay, so while teaching, which one we start teaching to the students to understand better? Is it the demand forecasting, or is it the inventory management? If so, why? Demand forecasting, yes. Why, sir? Okay, okay, right, that's great. So here, demand forecasting, yeah, anybody wanted to say anything? Yeah, before that I want to say, I want to hear from you guys, how many are teaching to the commerce people, how many people are teaching to the management students? Commerce. Acha, you're all teaching. So you're all teaching in the degree colleges or MBA colleges. You're also teaching to MBA students, right? Okay. Any MBA professors are there here? Okay. 1, 2, 3. Okay. Okay. Right. Right. Fantastic. Yeah. Yeah. As you said, you are perfectly right, because we start with the demand forecasting and then end with inventory management, because demand forecasting is going to predict how much you require, right? How much you want, and then accordingly, as a stores manager or a inventory manager, we are going to line up the inventory accordingly to see the availability in the marketplace. That's how we drive, right? So here, if you look at, I'll just give you some kind of the statistics, because the session is designed in such a way how the current scenario is driving everyone towards adoption of new technologies into their business processes, right? So this is how I have designed this. So here, if you look at the future of supply chains, because generally, if you look at the post-COVID scenario, pre-COVID and then post-COVID, how actually the supply chains have become more popular, right? And then we came to know more about logistics and supply chains management, post COVID actually, because we all have gone through, difficult times, and then there is huge shortage of, the various, products, right? And then the logistics has become more integral part of the our daily life nowadays. So everyone, because if something shortage is happening, and then we immediately think that yes, there is a problem from the demand side or the supply side, something like that we can, right? So here the future of the supply chains is poised for an unprecedented transformation, looking at the drastic developments in the technology, right? And then drastic, change in the mindset of the consumers, okay? And then competition existing in the marketplace, forcing the companies to, go for adoption of the newer technologies into their business processes. Same is the case with supply chain. See here, how come it is possible for a typical online retail company to always deliver the goods on time, every time? Look at how Amazon is doing the business, right? How Flipkart is doing the business, how this big basket is doing the business, how Blinkit is doing the business, okay? How various online retail platforms are doing the business. It's all by just managing the demand side, managing the inventory, right? Keeping the stock of inventory, and then they're trying to always deliver the things on time, every time. This is how things. So the beauty of the logistics we could see here when you are using the technology, because they started developing a kind of the integrated supply chain networks. The moment you place an order, right? The moment you are place, suppose if you look at the Blinkit or whatever, the big basket or anything, just you place an order, in next 10 minutes you are going to get your order to be delivered, right? How come it is possible? If you look at end to end, right, there is integration of all the stakeholders, and then your product is delivering on time at your place. This is what what's happening now currently, right? So the supply chains are taking drastic transformation in their processes, right? So here, going forward, imagine a world where every inventory decision is predictive and then real time, and then perfectly aligned with the customer demand, isn't it? Because that's how we are just sitting here, we are doing so many kind of the activities, right? And further, if you look at a world where hospitals never run out of the critical medicines, even if you look at, right? This is because of the adoption of the technologies into their the business processes. Simple as look at how Apollo is managing its healthcare operations, right? Apollo is having its own pharmacies. Even Apollo, you can even having online stores, right, where you can place your order, and then all the things are going to be delivered on time. This is how majority of the pharmaceutical companies or the healthcare organizations are adapting the technologies. And then retail stores always have the right seasonal products in stock, and then agricultural produce reaches the markets with the minimal wastage. And this vision is closer than ever, and yet significant obstacles are going to remain actually, right? This is how most of the firms trying to adopt the technologies into their business processes, and then stay always in touch with the consumers, right? That's how we are trying to experience always the kind of the luxury of getting the things on time, okay? And then supply chains today are burdened by the inefficiencies, right? Because wherever there is no integration of the stakeholders, yes, we experience always the kind of the demands and then the supplies and kind of the fluctuations, right? Suddenly some we experience in the marketplace, there is a demand side, and then there is a supply side uncertainties, Sometimes if you look at, there is a sudden increase in the prices of the onions. There is a sudden downfall of the prices of the tomatoes in the marketplace. So how it is happening? It is because of this kind of the uncertainties that we could see in the marketplace, right? And then according to McKinsey report, the survey recently, early adopters of AI, artificial intelligence enabled supply chain managements have achieved 15% reduction in the logistics cost and then 35% decrease in the inventory levels, right? And then 65% increase in the service levels. See here, I have taken this, supply chain into consideration because understand, expecting that you people are going to understand this easily. Supply chains have become so popular nowadays, where in which we can see the applications of demand and then forecasting we could see closely, right? This is how, because we are all teachers, I'm sure you must be knowing all these things, right? So this is how we can, and this is how, see, look at the real time data. If you look at 15% reduction in the logistics costs if you adopt the technology into the business process, right? And then 35% decrease in the inventory levels, and then 65% increase in the service levels. That's how, always we are, getting the quick response, right? Quick response logistics, efficient consumer response, right? Has become more practice, right, in majority of the logistics service, because they create a kind of the logistics pipeline, wherein which the moment you place an order, you are getting a communication that your order is confirmed and then just delivered. So quickly they check the inventory status, and then immediately they connect to the next level is partner, and then order confirmation is going to be happening. That's how quick response, right? Quick response is happening, and then everything is processed and then delivered. That's how majority of the service providers are always looking at reaching the consumers in the best, quickest possible way it is, right? This is how they are the kind of the statistics actually encouraging the organizations to go for adoption of the newer technologies into their business processes, right? That's how. And going forward, another thing is that in India, if you look at, in India, if you look at, supply chain inefficiencies lead to insignificant financial losses annually, particularly in the agriculture and the retail sectors. Look at this. Look at agri supply chains. Still, in India, there is a lot to actually take place, especially when you talk about, developing the agri supply chains, right? If you go to places like Haryana and then Chandigarh, that side, most of these, the retail, companies like, food companies which are into, the food products producing, right? So they have a close association with the farmers, and then they set up their own network, and then they use the technology like IoT devices and then other kind of sensors to get the real-time data, and then they start connecting the same with respect to their the data center, and connecting their understanding the demand, and then understanding the inventory levels, and then like that they're trying to always plan the inventory and then understand the demand and then reaching the consumers, because no one in the marketplace wanted to lose the consumers, right? This is how most of the firms are trying to always connect. Okay, and according to Deloitte report, if you look at, recent disruptions have slowed supply delivery performance, emphasizing the need for resilient AI driven supply chain strategies to minimize the risks and then improve the efficiency. This is how, because this is the statistics is showing that if our organizations are going to adopt this AI driven technologies into their processes, definitely there is a need. There is a, we can see the level of, the improvement in the service and then efficiency and then reducing the wastage, right? All these things we could see here, right? And if you look at the recent AI summit, India AI summit, took place in Delhi. Actually, it is a kind of, the program where we have got, variety of, the information about, all about, in AI, how AI is impacting, all of us, right, in our daily life, how, we have been, using these AI technologies, right, be it, the AI tools like, the Chat GPT or Perplexity or Claude or many other. There are so many kind of, the tools are available in the, open source, right? So you can access it, you can get whatever it is. But, if you are good at, writing a good prompt, you are going to get what you are looking exactly. Otherwise, again, it confuses you. So understanding the, the language of that particular, the tool is more important. How we have to, understand, we are all human beings, right? We have the human intelligence, right? So we need to understand the artificial intelligence. So in the sense, what exactly and how exactly it is trying to, work, and then what kind of, the information you are looking at, right? And accordingly, you just give the prompt, and then you are going to get the required information, and then just make the changes, and then read the report thoroughly, and then make the changes. I'm sure this is going to help you a lot. This is how, we how to, use the technologies in a more meaningful way, in the more responsible way, right? So Gartner report again estimates the AI can enhance the supply chain operations by improving the demand forecasting accuracy and reducing the inefficiencies and enabling more agile responsive planning, and then contributing to the substantial cost savings for the US retailers. See here, this is how, there are many kind of studies are there actually. So much of research is taking place, how AI is, actually transforming the entire business, scenario it is, right? So it is, we are just only talking about a small thing about, the demand and then inventory, demand forecasting and then inventory management. So inventory optimization, right? Depending on the demand forecasting, right? How are you going to, optimize your inventory at your store? This is what, we are going to discuss here. And then overstocking, on the other hand, what happens? Inflates the warehouse costs and then results in unnecessary wastage, particularly in perishable sectors like FMCG, pharmaceuticals, and the medical equipment, right? Overstocking also is the biggest problem, isn't it? See how nowadays most of the firms are actually going towards lean management practices, right? Lean operations, we can say it is. So some of the firms actually, trying actually, majority of the firms are, trying to avoid this warehouse concept actually, because warehouse concept is nothing but, you store all the goods, right? And then again, it is going to occupy the space, and then you have to make the payment again to that warehouse, maintenance towards all that. So what most of the firms are doing is, so majority, they are following this, just-in-time practices. While practicing this just-in-time, philosophy, right? What happens? Majority of their inventory is going to be in transit type, right? So exactly whenever it is required, the truck is reaching the plant, and then the inventory is going to be consumed. Like that, it is going to happen in a continuous process. This is how, the linear, lean operations are taking place, where in which, overstocking, all the kind of things are going to be removed. So everything is going to be, freshly, consumed in the marketplace, and that's how, it is going to be pushed into the marketplace. This is how we try to understand the importance of AI, how AI actually trying to develop the systems, trying to, make the systems to become, quick, faster, and then more agile in nature. This is how. So as a result, what's happening? We can reduce the wastage. You can, provide the best of the service, right? And then you are going to have always the, good customers with you, because what happens in the marketplace? So if when you start, reaching your, end users always on time, definitely, everyone is happy, right? you are the most delighted customer, right? So once people are happy, then ultimately, so they try to always look for the kind of the services. Earlier we used to be loyal to one particular product only, right? Now we have become loyal to several kind of the service providers, looking at their service, looking at the way they are responding to your, because after sales service also has become one of the most important aspect, isn't it? So these are all possible only when you are good in forecasting, right? When you are good in maintaining good inventory levels. We have to integrate both. We have to integrate inventory as well as the demand forecasting. Once you integrate these two, I'm sure you are going to get the best always on time. This is how come it is possible? It is possible only with the help of technology, right? So I'm sure you may be knowing the technology. What is the platform that you are using as a part of this workshop? I think Orange. Are you exposed to this Orange environment? So it is a user friendly kind of the machine learning applications where you need not write any kind of coding, anything, right? Just drag and drop and then just develop the models, you'll get the output. Bus, you're going to, that is the important, that is how the machine learning applications actually drastically changing the entire doing the business. Okay, that's how most of the firms are trying to adopt this newer technologies into their business processes. Okay, and now let us try to understand the demand forecasting and then inventory optimization, right? How? So here another example I'll quote you here. For example, if you look at the Asian Paints, okay, Asian Paints is India's leading painting manufacturing company, uses advanced demand forecasting with data from 100 plus points per dealer transactions. For example, knowing the weather conditions and then festive seasons and all the kind of stuff, and then to predict SKU level demand by pin code. If you enter pin code, they track with the pin code numbers, they generate the demand, how much it is going to be in that particular area, and like that they achieve 98% availability and then inventory turns for above industry average from 28 days versus the 51 days. Look at how drastic improvements in this. It is happening just only using the technology into their business processes, right? And further, for inventory planning, it maintains low finished goods stock. It maintains low finished goods stock, like the 7% of sales through the predictive replenishment, vendor coordination, and then AI generated systems across plants and then depots, and cutting costs by 45% while ensuring the timely delivery. Look at this, how beautiful this Asian Paints is doing the business in the marketplace using the technology itself. See how they have industry average have increased from 28 days to 51 days, right? And then demand forecasting here. Look at how inventory planning and how they are maintaining the low finished goods through the predictive replenishment, right? And then vendor development, right? All these things. So business analytics actually has part of has become an integral part of the business systems. Okay, where that predicting the demand, how much it is going to be, right? During the looking at the weather conditions, right? Again, there are going to be fluctuations during the festive seasons. Again, the demand may vary, it is, isn't it? Like this, they are exactly predicting and then trying to always manage the demand requirements in the marketplace. It is all happening using the AI driven technologies, right? And using the predictive analytics. Okay, we using the vendor coordination and all these kind of things. These are the kind of the tools which this Asian Paints is adopting into their business processes. So look at earlier, we used to, when the painting, when you are going for painting, right? So we used to have very limited kind of the options, right? Nowadays we have the unlimited options available, right? So it is just mixing everything and then it is giving an output of it is coming like this, like this, like this. So people will come and then test at your, wall, and then looking at that, we can pick up anything, whatever it is required. That's how, it is, possible we can, using the technology. And the another example, ITC Limited is there, right? ITC. ITC Limited is a major Indian FMCG manufacturer which leverages the AI-driven demand forecasting for its diverse products across its retail chains, right? So like general trade, e-commerce, tailoring models to channel specific needs such as quick commerce speed, all these things, right? Not only ITC, if you look at in the Indian retail companies like the Flipkart is there. Flipkart is doing the same, right? And then Big Basket is there doing the same, right? And then Blinkit is there doing the same. This kind of the predictive models, they're using it, right? That's how we can understand. And then inventory planning, what this ITC is saying is that it optimizing the stock using the digital supply chain tools for demand sensing, production mix, and then transfers, reducing the cost, and enabling over 100 annual product launches via pilot plans and then real-time adjustments. Look at this. This is how the technology they are using, with the help of this digital supply chain networks. What is this digital, twins, what we call it as in the operations, right? Digital supply chains. So what happens, it's, we are going to have the end-to-end integrated supply chain networks. Look at how, the retail firms like, the DMart and other kind of, the Reliance Retail, right? They're offering you kind of, the discounts. How come it is possible to offer the discounts, right, on MRP, right? It is just because of, this integrated, supply chain network only it is possible, right? So the benefit is this, given to the end user like this, we can understand, right? So further, the importance of the demand forecasting, if you look at how we look at in the marketplace. So demand forecasting is and as you know that demand forecasting is the process of the predicting the future customer demand for a product, right? And then it involves analyzing the historical data and then market trends, right? And then other relevant factors to make the educated guesses about the future sales volumes, right? This is how we can try to understand the importance of the demand forecasting, right? You are let's assume that you are a stores manager, right? How a typical retail stores managers are going to predict the demand, and accordingly they are going to keep the stock of inventory, right? In real time, generally, what they are going to do, they are going to highly rely upon the kind of data. What is the data? Point of sales information data, right? What is point of sales data? POS data. POS data is more useful to the stores managers to understand the kind of the demand which is going to be expected in the next the quarter, next the season, like these we can understand, right? POS data is nothing but the data they are going to capture at the time of billing, right? So let's say a store is having a customer footprint of, let's say, some 3,000 customers are visiting one store. Let us say the same is having some 30 stores in a particular city, and then across India there are several hundreds of stores, right? And then they get the massive information of the customers, isn't it? Let's say I'm purchasing some 40 products, right, per month, right? And then that is what we call it as the customer basket analysis. We try to understand how the customers are purchasing, what kind of products they are purchasing, right? And then how the products are moving out from the store, because stores manager is deeply interested always to see going out, all the products going out of the store actually, right? Because that's how the data is going to help the stores managers to understand what are the products moving fast, right? What are the items moving slowly? What are the non-moving items, right? FSN analysis in the inventory management, right? Fast moving items, slow moving items, non-moving items, right? So understanding this scenario, right, the stores managers are going to come up with a kind of the combo offers, right? So we experience this, we see always in the, any retail shops, right, with a, combo of, right, like, 5 kgs of oil with 5 kgs of water and then 5 kgs of sugar, right. So what made them actually to come up with this combo offers? This, the information, isn't it? This is how, we try to understand the importance of demand forecasting, right? So importance of demand forecasting and then using the forecasting tools, especially, right? Using the forecasting tools, and then now what we are doing, we are using this technology into this artificial intelligence. Earlier we used to do, manual things, and then, slowly what happened, then they developed a kind of, the tools, information system, I can say it is, right? And then if you give all sort of inputs, then it is going to give the, report. And then based on the report, we take the decisions like this. Now it is not like this. What is happening in the entire supply chain network? In the entire supply chain network, your data is, captured at the store, and the same is going to be, shared across the network immediately, and then accordingly they are going to, alert all the stakeholders in that, in the downside. Then accordingly, the entire inventory is going to be always, seen that it is available at all the points, focal points. That's how, we see the demand side. That's how, we see the how inventory is going to be, managed in the entire marketplace. This is how, right? So that's how we can understand the importance of the demand forecasting in the entire, the network, be it, in the supply chain network, right? This is how, we can, try to understand the concept of, the demand forecasting, right? And then why it is so critical, why this, demand forecasting is so critical, right? So here, because it is all about, it is going to help the businesses plan the productions as per the schedule always, isn't it? Demand forecasting is going to always, help the, businesses to always, plan according to the schedules. And also it is going to help the inventory management and then stock control always, the demand plans, because demand schedules are going to be released. Demand schedules are going to be released because, already the data is there. And then based on that, the stores managers are going to easily predict what going to be the next quarter demand, Q1, Q2, Q3, Q4, right? So like that, they predict the demand, and then they try to see always to procure the goods to keep in the store, so that, always they try to always see and, meet the demand requirements in the marketplace. This is how the scenario we could see in the, demand forecasting. And then it also going to help in financial planning and the budgeting also, right? The demand forecasting. And further, it also improves the customer satisfaction by ensuring the, product availability always, right? This is how, we try to understand the importance of the demand forecasting, right? So here, because the knowledge of, this demand forecasting and then inventory integration is highly essential when you are going to work on the tools, especially, any kind of, the tools. When you're, for example, when you are going to work on a orange tool, right? So you have taken the sales data of, one particular store consisting of some 1,000 customers, right? And then you uploaded it, and then you are going to generate the information, and then you wanted to predict the store's, requirement for the next quarter one, right? Next 3 months or the 4 months, whatever you are planning, right? Accordingly, it is going to give you kind of more, meaningful information, so that it is going to help you to keep the stock of inventory to meet the demand requirements in the marketplace. That's how, we can understand the, why demand forecasting is more critical to, understand, right? And further, now let us try to understand what are the models for forecasting, right? So can you guess what are the models for forecasting that you have taught in your classes? What demand forecasting models, Right. So here, Generally, we use this, extrapolative models in the demand forecasting, right? So the models include because this extrapolative models make use of the past data, essentially, preparing the future estimate by some methods of extrapolating the past data, right? So here, where in which we use the moving averages, weighted moving averages, simple moving averages, right? I think you know all these things, isn't it? And also the exponential smoothing and then time series methods, all this. This is what we call it as, the extrapolative models. And the other one is causal or explanatory models, right? So like, the multiple regression models and then econometric models, technological forecasting, right? So these are the causal or the explanatory models, and then subjective judgment methods. What is this subjective judgment methods? So here, this subjective judgment methods, nothing but, based on your experience and then expertise, we are going to predict the demand. This is how, see, this is how, we see, kind of, the models for, the demand forecasting normally. These are the models that we know now so far. Now, going forward, what's happening using the AI, right? What kind of models we could, use, right, in the artificial intelligence, right? So I'm not going deeper inside how we are going to work on this moving averages or the simple moving averages or exponential smoothing, right? And then trend, and then multiple regression models, all this kind of things, because you know all the things, I believe, right? So regression models, all this time series analysis, all these kind of things, right? So here, just only I'm sensitizing you just to, understanding all these models. How do we integrate in your, the AI tools? Because the knowledge of this is highly essential when you are going to work on certain kind of, the machine learning models, right? So this is how, we are going to. So these are the categories of forecasting techniques normally that what we do, right? So we, classify. One is, the trend forecasting. We can forecast the trend, right? You have a, massive data, I can say, the big data, what we call it as, right? So big data, using the data, you are going to forecast the trend, how it is going to be, right? So for the next, first quarter, second quarter, or, if you are interested, off yearly or yearly kind of, data, and then accordingly you are going to predict, and then you are going to see the trend, right, in the entire, the demand. And then graphical forecasting, it identifies the patterns and then slope trend lines to find out the insights that might have been, possibly missed, isn't it? This is, this is how, we are going to showcase everything in the form of, the pictorial representation, where in which you can easily, get it. And then quantitative forecasting, it uses the statistical methods and then historical, sales data, and then, going to predict what exactly you are going to work on it. That's how, nowadays this analytics has become so popular in the marketplace, and then it is generating huge, using the huge amount of data and then generating the reports, and then that's how, analytics profession has become so, demanding in the marketplace, right? And then quantitative forecasting, qualitative forecasting, it involves market research and then focus group interviews. Like this, we could, understand the various, the categories of, the forecasting, right? And then common demand forecasting techniques, if you look at, so here the time series analysis, what we are talking about, right? So in the time series analysis, we use the historical data to identify the patterns in the demand, right? And then also we, causal models. In the case of causal models, what happens? More, we consider the external factors influencing the demand, like, economic indicators or the marketing, offers, all the kind of, the things when we talk about the causal models. And then the qualitative models, which involves the expert opinions and the market research to gauge the future demand. This is how, we try to understand how the qualitative methods. And then machine learning and AI, because now this is most important actually to understand. Machine learning algorithms, can process the vast amount of data to make highly accurate predictions. Because machine learning has become so popular nowadays, and then that's why AI and machine learning combination has become more demanding in currently in the marketplace. That's how there is a great demand to this AI/ML professionals in the marketplace, because data we are generating, the massive data, it is big data, right? So you cannot use any kind of Excels and all spreadsheet analysis, right? So if you use this AI/ML tools, it is easy to segregate the information, and it is easy to see the trend. It is easy to understand what type of data it is, and then how we can use the data, right? Because the data analysis is going to give you a lot of the insights to understand, right? Lot of insights to understand in any kind of sector, be it in a manufacturing sector, be it in the service sector. Especially if you look at in the service sector, how hospitals are using this, how restaurants are using this, right? How a typical supply chain pharmaceutical companies are using this data, right? So using now, this is the need of the hour actually to adopt this technologies into their business processes, especially this AI/ML, artificial intelligence, and the machine learning applications. People who are experts in this area, I'm sure they are going to get good number of opportunities in the marketplace. That's why there's a huge demand to this the professionals in the marketplace. If you learn coding and at least one tool, if you can learn on that platform, you can work on it. There are several companies which are working on this kind of area, right? And these are the traditional methods versus the AI based methods. If you look at here, look at the traditional methods. These are the methods, we know that, right? Moving averages method, right? You know how to calculate the moving average, okay? 3 months moving average, 4 months moving average, 6 months moving average, right? Depending on the requirement. And also we know exponential smoothing, right? How do we calculate the exponential smoothing, right? Coefficients and all the kind of things, right? And then ARIMA is one of the tool, right? One of the most important tool where it's a kind of the auto-regressive integrated moving average model where we can calculate easily all that. And then seasonal decomposition, right? All the data is going to be used, because if you go, when we are going to discuss in the inventory, we understand all types of inventory. How do we connect that to the demand forecasting? That's most useful, right? And then AI based models, if you look at random forest is a AI tool, right? So it's a machine learning tool, it is, okay? So it's a completely the self learning kind of the tool where in which you can apply no need of writing any coding here, right? Just take your data set, then use this tool, and then I'm sure you are going to generate the output. And then XGBoost, this is also one of the ML machine learning tool, it is. And then LSTM, it is long short term memory, it is. This is also another AI tool. And then Prophet, it is a meta forecasting model, it is. So these are the AI models. Just only I have given indicated very few models, but you can there are so many kind of the models are available, right? When you're working on this orange tool, it's easy to understand because this is orange platform is designed on this machine learning platform only, it is, right? So you can just upload your CSV file, and then if you want to if you know what kind of information you want, right, then accordingly just connect it and then generate the report. It is so simple. Only thing, you need to have the sound understanding of that particular tool and what going to be the outcome, right? So that it is going to generate the information, and then accordingly you can get what you want. That's how we can use the AI tools in the entire business process. That's how most of the firms are, how they are trying to achieve the degree of excellence at the end of any business process. It is just because of the adoption of this the technologies into their business processes. Now it has become this AI has actually forcing the companies to adopt into their business processes. That's why there's a definite need that need to go for this adoption of this AI into the business processes. And now let us try to understand the art and science of this inventory management. What is this and how we can say this inventory management is a art or the science. So here if you look at the inventory management is as you know that inventory management is all about what we know all this, right? It's all about the process of ordering, sorting, right? Or using a company's inventory, right, which includes managing the raw materials, components, and then the finished products, all this kind of things, isn't it? When we talk about the inventory, be it in process inventory, right, or the finished goods inventory, all this kind of things, right? And here when we talk about the inventory planning, right, so you are a stores manager, right, or a supply chain manager, assume that. So what are the two most important decisions that we are going to mostly concern about when we are talking about inventory? We are mostly concerned about the quantity, right? How much to place an order and then when to place an order, right? So it's all about the queue, right? And then it's all about the time it is. So this is what we call it as economic order quantity, right? So time specific, typically talks about it may be the lead time, right? Or it may be the pipeline time, or whatever the time you are going to concern about it, right? So we are going to optimize. We are going to optimize here all these things, right? This is how we can try to understand the importance of the inventory it is, because as a stores manager we are going to concern about the inventory, right? So how are you going to procure the inventory? Based on the demand forecasting. Based on the demand forecasting, you are going to procure the inventory, right? So but while you are going to procure the inventory, first and foremost thing, you should know how much you want. How are you going to decide this? Based on the demand forecasting, right? When you want to require, right? It is again based on your demand forecasting it is. So this is how these two important decisions are most important when you are going to plan for the inventory, right? Inventory planning and then optimization requires the knowledge of when to place an order, how much to place an order. This is most important. Otherwise, if you are just like that, placing and then you are going to keep overstock of the goods at the warehouse and then no takers in the marketplace and then you're gone, right? That's how we are going to use the technology mindfully so that we can avoid all this kind of the things in the entire the process, right? So here further, what are the key objectives of this inventory management, right? What are the key objectives of this inventory management? How this inventory is going to help the managers to take meaningful decisions, right? So here inventory management, key objectives of this inventory management is always minimizing the storage costs, right? As a operations manager, I'm deeply concerned about the warehouse requirements and then how much it is going to be, right? Because I wanted to see always the availability of the goods always on time. If something goes delayed, then the entire the cascading effect you could see in the entire process, isn't it? That's why when you're going the key objectives of inventory management is to minimize the storage cost and then preventing the stock outs and then overstocking, right? Minimizing, so preventing the stock outs and then overstocking scenarios in the entire inventory, and then maintaining the optimal inventory levels always. Okay, so we try to maintain the optimal inventory levels when we are talking about the inventory, because otherwise what happens, stores manager is not knowing all about this knowledge of all these tools, and then just like that he's running and then he's gone, and then that store is not going to perform well, right? So how majority of the supply chain companies are going to take a decision in identifying the stores which are performing well, which are not performing well, based on this kind of the data only it is, right? So the data-driven approach has become an integral part of every business entity to take more meaningful decisions. Otherwise, you cannot just like that close the stores, right? And then you cannot just like that, remove the people from the job, right? So this is more important to understand, and maintaining the optimal level in inventory levels, and then improving the cash flows. Improving the cash flows, because the very objective of this inventory is that only, and then enhancing the customer satisfaction always, right? Enhancing the customer satisfaction, because what happens when you place an order through online, and then you expect some the delivery date at the time of booking. You are given some delivery date, and then your order has reached much advance. So what happens? You are the delighted customer, right? You are the most delighted customers, because you have promised, promised delivery is only 5 days, and then delivered prior to that 5 days, right? Within 3 days your order has reached your home. So ultimately what happens? We are the most happiest the customer, I can say, right? That's how most of the firms are trying to manage the demand side, and then most trying to manage the inventory side using this the technological integration it is. So once you as a stores manager or a retails supply chain the expert, once you start integrating this technology part, right, here with the demand forecasting and then inventory, then we could see the seamless operations, and we can win the people in the marketplace, and you can do the good business in the marketplace. That's how most of the firms are trying to always integrate these two with the help of technology, so that you can see the seamless operations with much more efficiency, right? That's how the most of the resilient supply chains have been designed and then developed, and then providing the best of the solutions in the marketplace, right? And further, let's try to understand what are the types of inventory, right? So what are the various types of inventory that you know, right? Types of inventory that you know. What are the types of inventory? Any guess that you know, or right? So this is one, seasonal inventory, right, is one type of inventory we can understand, right? So like the seasonality in demand is observed using the inventory. It is seasons, like during festive seasons, during winter seasons, right? Demand during winter season is different, right? During demand summer season, for example, ACs are there. During demand for this air conditioners is more during the summer season, right? And demand during the winter season is very less. Like this we can understand what comes under the seasonal inventory, right? And then what is the decoupling inventory? See here, decoupling inventory is it is all about the complexity of the whole production is controlled by using this splitting the manufacturing into stages of maintaining the inventory between these stages, right? What happens in the entire for example, if you look at any supply chain, right? Supply chain talks about the suppliers, and then manufacturers, and then distributors, and then wholesalers, and then retailers, and then customers, right? The end user. Customer is nothing but end user, we can say, right? So here what happening in the marketplace, so here the between customer to retailers, it is all about the customer order cycle, what we can say, right? And this is customer order cycle, and from retailers to wholesaler, it is retailers order cycle, and then wholesalers to distributors, and then distributors to like this. Look at this. These are the this is order cycles I am talking about at each and every stage of a supply chain network, SCM network, what we can call it is. suppliers, manufacturers, distributors, wholesalers, retailers, and then customers, right? Now, we're trying to understand the decoupling part of this inventory, decoupling inventory, right? We know what is seasonal inventory. We're trying to understand the decoupling inventory, right? So we wanted to see the continuous availability of, inventory at each and every stage, so that we do not miss any kind of opportunities going to happen in the marketplace. So we always try to create this kind of, the points of, inventory at each and every stage, right? Here we can create one, and here we can create like this, the inventory points where in which we are going to keep, stock of inventory at this decoupling places, and then we try to consume it. That's how, we always meet the in case of emergency. What happens, like, COVID side like situations are going to come. What happened during the COVID? China has become, China has developed, become more powerful actually during that, COVID, because they have well established supply chain networks, and the majority of the countries is highly depending on the China, because China is supplying variety of, the goods to rest of the countries on this globe, right? So suddenly there was a, problem, with respect to the transportation, distribution, all these things, right? There are no technologies to reach the people, right? So suddenly what happened, so most of the firms actually have become so resilient in adopting the new technologies into the business processes, and then started working on it, and then have become more resilient within a span of 6 to 8 months, and then bridge the gap between demand and then supply in the marketplace. That's how most of the firms, especially in the, in many of the business sectors, actually started, looking into this, supply chain network design, and then understanding demand and then inventory more closely using the technologies. And then cyclic inventory. Cyclic inventory is a periodic replenishment causes the cyclic inventory in the entire inventory pipeline. And the pipeline inventory, what is this pipeline inventory? Pipeline inventory exists due to the lead times in the entire, the supply chain. And then safety stock. Safety stock is used to absorb the fluctuations in the demand due to the uncertainty, right? This is how, we can understand the various types of, inventory, how it can be seen in the typical supply chain network. And this is all about, to understand the cyclic, pipeline, and then safety stocks, right? I'm sure you must be knowing, right? All this graph you see here, this is a cyclic stock, and here it's all about, the time we can take on the, horizontal axis, and the quantity we can take on the vertical axis, right? And then, here the moment you reach here, again you are going to place an order, and then that's how, your cycles, continues. And this is what we call it as in the lead time, and this is a reorder point, what it is, right? The moment you reach here, and then you are going to place an order, and then the cycle continues, right? That's how we can understand the concept called, the cyclic, pipeline, and then safety stocks in the inventory management. And here, when you talk about the cyclic inventory, the pipeline inventory and safety stocks are critically linked to the how much decision, and then inventory planning is linked to the, when kind of, the decision. This is how, we can address how much and when with, respect to this, the inventory, inventories what we have, discussed so far it is. So there are two major decisions, right, in the inventory planning. So how much and then when to place, so the quantity and the time bus. So to understand this, then we need to understand the cyclic and then seasonal and then decoupling and then pipeline, all this kind of stuff, right? So that it is going to help you when you are going to work on any kind of machine learning application, right? Because you may get a doubt like, why there is a need to understand all these kind of things, since you are using a machine learning application, and then just a matter of placing it and then generating the report. But what do you do with that without knowing the basics of things, right? So that's why, people who are, working in the area of this, operations and then supply chain, right, are going to, typically concern about this, and then they are going to draw more meaningful reports, and then accordingly they are going to design the more, resilient supply chain networks, right? So now look at this. We'll see one small, activity here. It's a small problem. So they just wanted to, see how, you are more acquainted with the inventory management. So it is a small, problem, just can take 2 minutes or, 3 minutes of time, and then just read it and then work on it. Can you find out? Can you find out what is this order quantity, and then can you find out the what is cyclic, inventory in the system here, looking at this problem? So here, a manufacturer of transformers requires copper both in plate and then wire form as a key ingredient. The lead time for the supply of copper is 2 weeks, and if the manufacturer places monthly orders of copper, analyze the various types of inventory in the system as indicated, right? Can you work out quickly on this? What is the order quantity here in this problem given? And then cyclic inventory in the system, and then lead time, average weekly demand, and then pipeline inventory. Just can you quickly do this so that it helps you whether you can you are aware of this inventory or not. Yes. So I am sure you got the answers here. So here the weekly requirement, average weekly requirement is given, and lead time also is given. Cyclic, what is the cyclic inventory? What is the lead time? What is the average weekly demand? What is the pipeline inventory here? Any answers? First one, okay. Okay. So first question is order quantity is 800 tons. You got it? Very good. And then cyclic inventory 400 tons, because it's a Q by 2, right? Cycle. And then lead time is 2 weeks, right? And then average weekly demand 200. Then what is the pipeline inventory? It is all about 400, because this lead time into the demand, it is 400 tons. It is simple, because people who are having this small simple concepts, they can easily do good when you are going to work on with any kind of the application, right? The knowledge of this is highly essential when you are going to work on this kind of the applications, right? And now let us try to understand the further what are these inventory management strategies. How a typical the operations manager is going to deeply work on this inventory management strategies. The first and foremost thing is the just in time, JIT, right? JIT philosophy, right? So here this strategy aims to reduce the inventory holding cost by receiving goods only as they are needed in the production process. This is what I am saying, the lean operations. Our firms are moving towards the lean operations, lean thinking, reducing the wastage. Okay, so just in time philosophy it is, right? And then the second one is the ABC analysis. You must be knowing this ABC analysis, right? So here this method categorizes inventory items based on their importance and then value to the companies. And then economic order quantity, EOQ, right? You know this UOQ, what all about. And then this model determines the optimal order quantity, which minimizes the total inventory costs, isn't it? And then other one is the safety stock, which involves, keeping extra stock to prevent the stock out scenarios due to the unexpected demand or the supply chain, disruptions, isn't it? So this is how, we see the kind of, the strategies, inventory strategies that normally we can see. And then vendor managed inventory also is another, strategy where, the suppliers take the responsibility for maintaining the retailers inventory levels, right? And other, if you look at the demand and inventory and the demand forecasting models, this is what we have seen, right? Like, the moving averages, exponential moving, smoothing, ARIMA, and then random forest. Random forest, as I said, it is all about the supervised learning technique algorithm, which has built on this, machine learning, and then XGBoost, like, which is a machine learning algorithm again, and then LSTM, neural networks, and then inventory models like, UOQ models, and then news vendor models, and then continuous review systems, safety stock under uncertainty, and then multi-echelon inventory systems, right? These are the various inventory and the demand forecasting models. Here, what you people are going to do is that when you are going to work on this orange platform, right, you are going to be given a kind of, the data set, and then you are expected to run the data using these tools. All the tools are going to be available, like, the multiple regression models, time series data, right? And you can generate the reports. It's easy to understand, and then you are going to, make the interpretations of the same it is, right? And then inventory optimization, if you look at, for example, here the question is, what is the most fundamental objective function in the inventory, optimization? Effective utilization of the, what is the most, fundamental objective function of the inventory optimization? What is the fundamental objective? Reduction of the stock outs, stock level, maintaining the stock levels, right? So here, as you know that here, always minimizing the total cost in the inventory, right? When you are going to optimize, we are always going to minimize the total cost, right? So total cost, which is equivalent to ordering cost, holding cost, and then stock out cost, it talks about, right? So here it formalizes the economic trade-off between the ordering, because what happens if you look at this equation, ordering too much and then ordering too little, again going to be a problem. So we have to trade off this cost, right? And then the total cost function, if you look at, it is all about, this is what exactly the equation, what normally we are going to use it when we are going to talk about the, optimal, inventory, right? So total cost is equivalent to this D by Q into S, where D is the annual demand, right? We know all this, and then Q is the order quantity, and then S is the ordering cost per order, and then H is the holding cost, right? Here, each term represents a different cost driver when you talk about it, right? And further here, if you look at the trade-off mechanism, when you're talking about this, fundamental objective of this, inventory is that because the smaller the quantity, higher the ordering cost, right? Smaller the quantity and then higher the ordering cost, and then the larger the quantity, higher the holding cost, and then lower the safety stock, and then higher the stock out cost, right? Therefore, the optimal solution, balances all these three actually. That's how, we are going to deeply concern about this, right? Minimizing the total cost. The fundamental objective of any inventory is to minimize the total cost, right? So when you are going to minimize the total cost, you are going to concern about the ordering cost, and you are going to concern about the holding cost, and then stock out cost, right? So we can infer that. So smaller the Q, right, and then higher the ordering cost, larger the Q, and then the higher the holding cost, like this, right? And then further, under uncertainty conditions, we can also, look at, because demand during the, demand during uncertain conditions, demand during the certainty conditions, right? So here DT is, where we can see the trend, seasonality, price, promotion, macro, noise, all these are, uncertainties, right? Which create uncertainty in the system, right? So during this period, again, predicting the demand is more important, right? Understanding and keeping the inventory levels during the, uncertainty, during, uncertain times also most important aspects, right? So this is the generalized demand generating process, which is used in the most of the forecasting models, right? And then, when you are going to work on this kind of, the uncertainties, right? So what happens? This tool, AI going to enhance all the forecast accuracy, right? And then, real-time responsiveness, and then multi-variable integration, like this, we could see the how AI is, AI is going to enhances the entire, the network, right? And then risk simulations, right? This is how we try to understand when we are talking about, the big data. When you are going to big data, right? So it is going to always, enhance the entire, the network, and then you see the continuous, availability of the products into the marketplace. This is how we could see the how AI is going to enhance, especially in the when you are going to optimize the inventory levels in the entire supply chain network, right? And then intersection of demand forecasting and then inventory management, if you look at, because as I've been talking about, we need to integrate this demand forecasting and then inventory management, right? So how are you going to integrate this, right? So here, while demand forecasting and inventory management are distinct concepts actually, and then they closely interrelated in practice, what we are talking about, and the accurate demand forecasts inform the inventory decisions, while the effective, inventory management ensures that the forecasted demand can be always met. So it can be possible with the help of integration of the technology, then we can, bridge the gaps between both actually, right? So here, the benefits of integration of these two, actually, what happens when you are going to integrate this demand forecasting with the inventory using the AI tools, right? It is going to improve the inventory turnover rates, and also it is going to reduce the carrying cost, inventory carrying cost, and then it is going to enhance the customer service levels, and then better cash flow management, and then increased profitability, right? This is how we could see using these AI tools in a demand when you are integrating forecasting with the inventory optimization, right? So we can reduce lot of, the work and lot of time, and then we always streamline the entire workflow, right? And further, the challenges, what are the challenges in integrating this, right? What are the challenges in integrating this demand forecasting, and then inventory when using this, AI tools? So here, data quality and the consistency is the biggest, challenge when you are going to integrate this, and then handling the seasonal variations and the trends, again becoming a kind of, the bottlenecks I can see. And then dealing with the long lead times, also one of the major problem when you are trying to connect this demand and then, the inventory. And then, managing the product life cycles also has, become, challenging. See, look at nowadays what's happening in the marketplace, drastic changes in the mindset of the consumers one side, and then drastic developments in the technology other side, and huge competition existing in the marketplace, right? Forcing the service providers to go for the shorter product life cycles. There are no longer product life cycles, right? There are no longer product life cycles nowadays in the marketplace, only the shorter product life cycles, right? How come it is possible? Just possible with the help of this only it is. So that's how, service providers started thinking in the perspective of the end users. That's why in the marketplace we are getting, whatever the products we are getting in the marketplace, it is very close to, I can say 80% close to of, our expectations, right? This is how, majority of the firms are, doing the business in the marketplace using the technologies, and then balancing the service levels with inventory costs is another the challenge when you are going to integrate both. And let's see the technology in the demand forecasting and the inventory management, how it is going to be, because we have to integrate this when you are going to generate as a retail stores manager or a operations manager, right? You need to have the sound understanding of the data set, and you need to sound understanding of the implications of the demand and implications of the inventory, so that you can get the best of the results, so that you can avoid lot many kind of confusions in the process also, right? Because technology is a crucial in enhancing the demand forecasting and inventory management process in the today's digital age, right? So that's how today whatever data is captured, immediately it is going to be shared across their entire network. That's how they're trying to understand the market, and then they're trying to predict what's going to be the next, and then that's how they're going to meeting the demand requirements, right? So the advanced software solutions, what most of the firms trying to adopt, right? So like ERP systems and specialized supply chain management softwares offer the robust demand forecasting and then inventory management tools, right? ERP, now popularly known as the SAP systems, right? SAP, what we call it as. And then these systems can process the large volumes of the data so quickly, and then provide real-time visibility into the inventory levels immediately. Quick calculations, you are going to get it once you start working on the data, and then generate accurate demand forecast using the advanced algorithms, right? And then automate reordering processes, and then offer the detailed analytics and then reporting, right? This is how the big data applications are going to be seen in majority of the systems. And the role of the big data and analytics, if you look at, and see here, big data and artificial intelligence are revolutionizing the demand forecasting and inventory management. See here how most of the firms are working on this big data applications, how they are coming up. How come possible to Walmart always to offer the daily discounts to its customers in the supply chain, right? And not only that, if you look at majority of the e-commerce firms also doing the same. And then machine learning algorithms can identify complex patterns in the historical data. That's how we can use this machine learning applications. And then AI can consider a wide range of variables to improve the forecast accuracy, right? Because when we are working on the forecasting models, we also look at the forecasting errors, right? So this, it's going to give you the more accurate kind of the results. And predictive analytics can help and anticipate future trends and potential disruptions what's going to be seen. And also Internet of Things, IoT devices can provide real-time data on inventory levels and the movement also, even IoT devices, right? That's how we can understanding this how to leverage these technologies is becoming increasingly important for the entire supply chain professionals in the entire domain of supply operations, right? And the future demand forecasting, what is the future of demand forecasting and inventory management, right? So here in the light of this technology, so what we could see here, the first and foremost thing is the the increased automation, right? So this increased automation, like the robotic process automation and autonomous vehicles are set to revolutionize the warehouse operations and then inventory management. Like look at big size warehouses, how Amazon is managing its warehouse in Hyderabad. They deployed robots into the processes. The moment the order goes, and then it's going to pick up, and then everything is through driven through the barcodes, and then no human touch. Only at the last mile delivery, it is going to be delivered to the customers. That's how the fully automated technologies have come into the process. And then greater integration, right, is another kind of things we can see. And then sustainability focus, right? Most of the firms nowadays focusing on the sustainability kind of things. And then enhanced personalization it is, right? This is how we could see how demand forecasting and inventory, we could see in the future how it is going to be. And then blockchain technologies, adopting the blockchain technology into the entire, the business process, where, we could see more secured kind of systems, right? And then how, efficiently they are, delivering and reaching the, end users in the marketplace. This is how, we could see the, future of, demand forecasting and, the inventory management. And then AI revolution in the optimization, AI optimization, how do we look at this? So here, this traditional inventory management is built on the forecasting methods, right? So which often always, fail in the face of, the demand volatilities, isn't it? So here we are adapting this AI into this inventory. So the classic example, if you look at the festive season shopping surge, if you look at, right? So where, lot of, uncertainty, right? And then whether it is the change of seasons or end of quarter sale cycles or the major shopping periods in India or any other country for that matter, retailers are going to struggle to predict demand accurately and leading towards, either, stock shortages or the excess inventory, right? Like this, these kind of scenarios we could see, right? And then in a hospital, critical medical supplies, like ventilators and essential drugs and need constant tracking to prevent shortages that can have life or death consequences also, right? This is how, we can also look at this. And then AI revolution in the inventory optimization, how do we look at this? We can see this AI powered inventory optimization changes this, equation by leveraging the technologies like machine learning, predictive analytics, and then real time data processing. That's how, machine learning has become so popular. Applications of this machine learning has become so popular, and then, it is, giving smarter solutions to majority of the service providers, right? And then this is how, we could understand the shift aligns closely with the Indian general budget. Like, if you look at last year, how Government of India is presented, which places a strong emphasis on AI adoption across industries. Yep.
Same floor, you need not go down. Just come here, left, second floor. Computer, first. Thank you.
Right. I'll quickly wind up it in next 2 to 3 minutes. Okay. Right. So here, what I'm trying to say is that, in last year, the Government of India announced the importance of this AI technologies, and then see, look at this, this year they have, quickly come up, with a kind of, India AI summit. That's how, bringing the technologies, right, creating a kind of, awareness, right, to all the stakeholders. So, important actually. So this is another kind of, the revolution I can say in, adoption of technologies into the business processes. So here, efficient AI powered inventory management will always help, or play the crucial role in handling this, surge in the demand, right? And also minimizing the post harvest losses, especially in the agriculture sector, right? And then Big Basket, one of India's leading online grocery platforms, also using this, AI tracker mechanisms, right? And then this company uses the AI to track, purchase patterns, predict regional demand, and automate warehouse restocking, all this kind of, the things as, quickly moving actually. And then by fine tuning the inventory levels through this AI, the company Big Basket actually has reduced wastage by nearly 35% while improving the order fulfillment rates. This is the beauty of, the technology, that's how, these companies are managing, though they don't have any, warehouses, right? They don't, produce anything, but doing a great business using the technology, right? So the need of the hour is adoption of, this AI into their business processes, actually making everyone more comfortable and providing, smarter solutions, right? So why this inventory, is forecasting is more important. So because inventory forecasting helps the retailers plan and optimize the inventory and cater to the customer demands, and then overstock, stock outs, all this kind of thing. And then demand this, this is a generic thing, it is. This is not connect, it's a loose connection. there's a loose conduct. Yes, there's a technical problem. Because this came now? Yeah. Just we are at the fag end almost. Yeah, you see here, I'm talking about how this AI is transforming the supply chain and inventory optimization in the Indian MSMEs, if you look at. So here, because here this MSMEs become an integral part of the entire network. What is the problem here? Okay. Not. एक minute. While we are, yes, okay. Yeah, okay. Leave it, leave it, leave it. Okay. Okay, fine. Just only I just thought of presenting you what exactly this how AI is transforming the supply chains, because as I said, in a typical supply chain, if you look at, there are several stakeholders, as I have written here. At each and every stage, the applications of this artificial intelligence has become mandatory now, right? Most of the firms are how the data is generated from here to here, here to here, here to here, like this. So they're coming up with a variety of the patterns of understanding the data, and then providing the services to its next level customers. This is what I'm trying to say actually. It's okay, right? So finally, it is all about the ethical issues related to AI. What kind of the information now we can, because we use the variety of information, right? Because everything has become open access, right? So while you are using the data from any source, right, we should be ethical, right? And we should be mindful, we should be responsible what we are going to use it, right? So here, because the issues related to the use of AI is typically algorithm based and then unfairness, because you do not know the reliability of the information, right? Whatever you are looking for the information, then it is generating it. But what is the reliability of that? How are you going to check it? So you need to have the sound understanding of that to understand the machine language, so that we can easily finalize and then take more valid kind of the decisions. And the data privacy and the surveillance are also one of the important thing coming under ethical issue. And then privacy concerns arise when you're talking about this AI usage, from handling sensitive sales data without GDPR compliance, and then while block box models lack transparency, eroding trust in the decisions. All this comes into picture actually, because when you are going to use this privacy concern, whenever, I am sure you must be knowing, when you are going to agree any kind of things, at the end you are going to tick mark the terms and conditions to use your the data. The data privacy also one of the most important aspect. And then accountability for errors also, because we do not know how exact the output is generated by that AI tools, but you have to look at its data accuracy and then its validity, right, using your own knowledge. And displacement and autonomy in operations also we could see. Fairness and accessibility in learning also another fact you need to. And then transparency about the limitations, and then over reliance, and then academic integrity also another factor when you are talking about ethical concerns, right? Ethical issues related to the usage of artificial intelligence. Today you are using ChatGPT left and right, and then we do not know anything about the reliability of the information what it is produced, right? So you need to check its reliability, right? You are more accountable when you are using that the data, right? And then hidden commercial agendas also there, right? sometimes, what happens, some of the people use the data, for commercial purposes also it is, without taking the consent from, the stakeholders, right? This is how we could see how, the ethical usage of, the AI, right, in general, in our, personal life and the professional life also we could see it is, right? This is how we can try to understand the importance of this, the inventory optimization and the demand forecasting using, artificial intelligence, right? I'm sure when you are going to work on hands-on experience, you'll get to know how this machine learning applications are going to populate the data output, so that you can, you love it actually, that work environment working on that orange platform. It's only machine learning based, application. Drag your data set there and then just connect it and then, populate the data. Very simple one. Very simple. It is not like your SPSS or any other kind of, the statistical package. Okay. No coding knowledge is required. Just only you should know what kind of output is required. That is most important. Okay. So with this, I can conclude. So here, what I am trying to say is that demand forecasting and inventory management are critical to any successful, supply chain strategy. And then these areas are complex and then interconnected and rapidly evolving as we, have, explored. And developing expertise in these areas is essential to build a career in the supply chain management. Why I have taken this supply chain is because in the supply chain management, we typically deal with this demand side issues, supply side issues, and then inventory issues. So if you have the sound understanding of this demand and then inventory, then it is easy to understand the concepts to work with your, machine learning applications or any other AI related tools when you are generating the outputs, right? So during the lab exercise, I'm sure you may, get to know more about the applications of this machine learning and then other kind of, the tools, right? So with this, I'm concluding. If you have any questions, you are most welcome, right? So thank you. Any questions, please? Right. If you don't have any questions, we can, call it a day now. So thank you very much. Thank you very much for your patience listening. I'm sure because you're all teachers. We're all teachers right here. We're all teachers, and then, talking the same things. I'm sure some people must have felt like, we are, we have already know all these things, and then again learning all these things. See here, learning is a continuous process, right? We learn from each other. Okay, we learn from each other. Learning is a continuous process. So don't, feel shy. Don't hesitate to ask any questions. So we are here to, learn from each other, right? So thank you very much for your patient listening. I appreciate all your efforts in learning the new technologies as a part of your teaching learning process. Thank you all. Have a good day.
Hi everyone. So hope you had a pleasant lunch break. So this is a privilege for me to introduce Dr. R. Prashant Kumar. He's a faculty member in School of Management Studies at University of Hyderabad with expertise in finance, accounting and entrepreneurship. He's an alumnus of IIT Indore and Sri Venkateshwara University Tirupati. Before joining UoH, he served at National Institute of Food Technology, Entrepreneurship and Management, Kundli, an institute of national importance under the Government of India. His academic work includes guiding master's and doctoral research students in finance and related fields, publishing in ABDC or Scopus Index journals, and leading sponsored research and training projects. He has also conducted faculty development and entrepreneurship programs and received awards from University Grants Commission and Asia Productivity Organization, Japan. Additionally, he engages in extension activities like financial literacy education and continuous research in capital markets, corporate finance, and entrepreneurial finance and fintech. It is indeed a very big privilege for me to introduce our very own Prashant sir. Over to you, sir.
Thank you. Thank you, Anusha. Yeah. Just before we are going to start the session, I thought of it to ask you, those who are teaching I hope all of you are from commerce background. Yeah. So how many of you are teaching the courses related to finance? Oh. What course do you teach, ma'am? The name is stock market operation, your course name. Yeah, about you, sir. No, it's okay. No, I'm asking about related to specific to finance. Okay. Okay. So stock market operations. Next, financial accounting, financial management. Wonderful. Yeah, here somebody has raised here. Anyway, yeah. Yes, sir. Please tell me. Okay, fine. Wonderful. See, though you are very few related to finance, but I know only finance. You have to bear with me. That's all. Please understand. Okay. Now, otherwise, what I will do, we'll take some general discussion. Then we will link up to how you can use AI tool for the general discussion. Okay. Our presentation is planned. This is very brief. So after completion of this, what you call, we are going to use what about business intelligence in finance, and how can you build your predictive models. The reason why I am using orange, we are being instructed to use orange. Okay, so that's why everybody might be using the same orange. The idea is so that you will become well versed with working with that. If different teacher teaching different kind of tool, so you may find difficulty. That is the reason every teacher is using orange. Okay, and so we'll be going to conduct some kind of hands-on a practical session in your computer lab. So first session is theory, we are going to discuss here. Then later on we are going to do practical. Today I have with me my own PhD student. He is going to help us in conducting these practical sessions with us. Okay. So now if you bored by this time, I can skip this slide also. So otherwise, the idea is, I thought of to discuss with you. So what is meant by analysis, analytics, and what happens if you are going to incorporate AI into your analytics. Okay, so this is about. So this is, say, this analysis, it briefly gives some sort of, descriptive idea of your phenomena. Descriptive idea, like those who are, teaching, statistics, you might be knowing some kind of descriptive statistics. Yeah. Yes. So what about mean, mode, or measures of central tendency? Some kind of, descriptive analysis based on, in general, historical data. Historical data means the data which you have already collected, archival data. Now we are conducting some descriptive interpretation out of this data with the help of whatsoever the software or package that you are well versed with. For that matter, you might be doing even the same thing by using your MS Excel also. Okay, when you are trying to look out in analytics, the kind of data which you are going to use in analytics, the volume, velocity, you might have bored by this time, by listening those kind of words. Big data, typically we manage big data, and not only that, we strategize. How can we strategize? Strategize means, strategize, okay, means strategy. Okay, so we are going to implement strategies. Okay, so now how we are going to make, strategic decisions? So with the help of, when you have, large amount of data, you might have heard certain words called, predictive analytics, prescriptive analytics kind of thing. Okay, so in prescriptive analysis, normally we employ certain amount of, statistical techniques only to understand the historical data, historical variable, by, say, conducting, regression analysis. For example, you wanted to know what is the impact of advertisement or sales promotion activity on your sales. So just we are going to conduct, some, so prescriptive, so predictive, what are going to happen when you are going to prescriptive? What will happen to sales if you are going to implement some more strategy? Okay, that is known as prescriptive. So descriptive, okay, so prescriptive, and so analytic. Okay, so this way, predictive. These are the three things. We apply these kinds of, concept very well even in finance also. Now, then what is the role of AI here? Okay, so there are sophisticated softwares are available to conduct your, say, descriptive statistics or prescriptive statistics or even your predictive statistics. Then what is the need of AI? Anyone want to try? Why AI? Good, it will be simplified, but we will be facing challenges, everywhere. Even AI won't give, or predict 100% accurate. Customization of the information. Anybody else? It may give you more inferences, incomplete. See, when you are doing, manually your analysis, either with descriptive or even, predictive analytics based on historical data, so it inherits always bias, manual bias, or otherwise, manual emotion. Okay, so when you are bringing, emotions or bias into the decision making process, especially financial decision making process, there are chances that the decision may go wrong. Say, for example, since, one of our colleagues are teaching, stock market operations, both of you. But you should have maintained your nameplate, so that I would have called you by name. Okay. So when you try to look at these two people, what they are saying that they are teaching stock market, operations. So now when you are discussing the concept of this AI, what will happen? We do trading or investment with always some kind of bias, or certain amount of so tendency. Say if everybody sells the stock, then we try to observe the market. Okay, there is certain thing is everybody is selling the stock of TCS, then I will also sell. This is one herding. So our behavior will become like herd behavior. So when the group of the people are doing the same thing, then I will also do the same thing. It is one kind of bias. Sometime same related to stock market, you might be having some poor confidence. So those who are I don't know how many of you are doing intraday in this class. Class in the sense generally some of the participants will be doing intraday. What will happen if you are going to execute your intraday orders, if you are going to place your intraday orders without stop loss?
Sometimes you end up in loss. Use losses, maybe.
So why it is? So why he is not keeping or executing stop loss? Overconfidence bias. Overconfidence bias. In literature wise, in finance decision making literature wise, we call it as overconfidence bias. Okay, so likewise, there are n number of bias. Sometimes anchoring bias. There are different bias. So now the point what I'm trying to say that when you are applying bias into your decision making process, all the chances are that the decision, your financial decision may go wrong. So why? We are giving our brain or our emotion, and you know very well all of our emotions are not rational. To overcome this drawback, if you are going to adapt AI tool, it will think machine, otherwise I would say machine will think without any prejudice or without any bias. So that is the reason why we should encourage your student to learn finance through AI tools. So it will try to eliminate all kind of human bias. And secondly, as you said, it doesn't actually require any coding. So I think all of you are attending looking at this orange application, etc. Have you really written any kind of code for your programming? No. That is the another advantage. Though you are from non-technical background, so without any technical knowledge, still you can make decisions with the help of AI. Okay. Now I told all our decisions are backed by historical data or historical thinking. Have you ever heard of the concept called streaming data? Streaming data or live data, real time data. Now I think you got your case study by this time. Have you got your case studies? Yeah, please. Now we are going to get your case study. Default, credit default. Second one. You try to take second case from this booklet. Second page, second case you have to prepare. Yes. I am going to ask you questions from that case, so please read carefully. Thank you. Done? Yeah. Now just I would like to understand, assume you are a banker. Okay. You are scrutinizing, lot of applications on daily basis. I strongly believe any loan process will start from rejection to acceptance. So means while you are receiving application, they think always what are the ways to reject the application. Then as such there is no other way to get rejected, then it will be rejected as an acceptance. This is the way how typically banks think while scrutinizing or while conducting due diligence process of loan application. Okay. Now when you are approaching, assume you are a banker, you have a lot of applications with you. Now you have to consider, so what are the parameters you are going to consider to sanction the loan. Okay, so based on this, what you call your case information, could you tell what are the factors will you consider? Age. So income. So employment. Loan amount, loan history. What you meant by history, madam? You want to say payment history, repayment history? Oh, default history. Next. Credit score. Pardon. CIBIL score. Yeah. Credit score, CIBIL score, one and same. Yeah. Family background. Culture. Culture means what? How do you define? Very good. How do you define? Hmm. Hmm. Next. You can tell any points which are not being covered in this case also. You can tell other points. Number of transactions. Spending. Very good. Debt equity. Mortgages. Yeah, fine. So already the existing pre-loan for us, Any other thing we have missed? Bank statement. Collateral. Operating ratio. So could you elaborate what do you meant by operating ratio? Yeah. Now, yes. Yeah, bank rates. No, from customer applications, we don't expect those data, madam. That is, from management perspective. But otherwise, from typically from customer, what do you expect? Or what kind of, factors from customer will, so trying you to take a decision whether to sanction the loan or not sanction the loan, unless you are going to confirm he is not going to likely default, then only you will say accept, your application is accepted. Yeah, profession, employment, yes ma'am, correct. Now, don't you think that these are all historical data? Okay, these are all historical data. So you said they ask 1 year bank statement. They will ask you 1 year bank statement, or say 6 month salary statement. So these are all historical data. But do you think that this historical data would alone sufficient to deciding the credit worthiness of a loan applicant? Yes, sir. Yes. So there might be certain kind of risk and uncertainty. That risk and uncertainty not necessarily captured in your history or historical data. See, now when you are going to apply, assume these are your data set. When you are going to use this data set for the purpose of your say descriptive analysis or even your predictive analysis, okay, so it's okay. But what else if? The reason is, there are certain things which may force you. Say suddenly, assume a person is a corporate, earning, so working for a, software company, suddenly lost his job. In history, there is no capture of what you call job loss. But don't you think that the sudden loss of job is going to create impact on his EMI payment, repayment? And somebody was referring you, rightly said, spending analysis. What is meant by spending analysis? Say if somebody is, extensively using credit card, like say that is a very abnormal usage of credit card. What actually it indicates?
He doesn't have any financial.
He has certain issue with his finances. So what I want to say that the factors are not static always while making financial decisions. The factors are dynamic. Yes, that will be. Yes, that's okay. That's okay. Fine. We have captured your historical data here, or historical variables. But my only point is, so the entire business or the economy, ecosystem is based on, dynamic in its nature. That too, due to emerging technology upgradation in almost all business. Okay, now days are gone, Now hardly we need cash to any kind of transaction. You have emerged. Okay, so then these dynamic incidents or dynamic factors not necessarily, say for example, occurring again and again. It might be like COVID, for example, which we don't know. So when you are going to encounter such kind of dynamic environment or dynamic incidents, so at the time these dynamic incidents will also impact the credit worthiness of an individual. So the idea of this session is how you can consider these dynamic factors while conducting due diligence of loan application. So we know historical factors, we can make some analytics, predictive models, we can conduct likelihood, okay, whether he is going to default or not default, we can do that. For that, statistics alone is sufficient. But the business environment or the economic environment is not so static in its nature, it is highly dynamic. When if it is highly dynamic, then the role of AI will come. It can capture, machine can learn the new trend in your data set and it will act accordingly. You don't need to think of it. Without emotions, it will operate on its own. So that's why we have to train your own students application of AI in finance learning especially. I have mentioned these are some of the areas, and last also I am going to show you where you can actually apply AI. The only intention is what? To handle dynamic data and as well as to avoid all kind of human bias. When you are going to tackle these two things, then your decision will be most likely, better when you compare with any other form of decision process. Okay, now we are discussing about what you call this streaming data. Say we are telling a person is extensively using a credit card. Okay, it is giving you some kind of signal to you. Now Can you imagine when you are trying to use any app, fintech application, this fintech application can measure the tone in which you are typing, tone of typing. So you might be operating some typing words, stroke, okay, your stroke. So it can measure the tone of your stroke. Based on that, it will assess the psychological position of the individual. That is the advancement of finance. No longer only with your historical data. The tone in the way how you are typing on your app, it will give some kind of information. I am not saying that we should not consider this historical data. Besides historical data, you have to consider this real-time or streaming kind of data also to improve your decision making process or minimize errors in decision making. Okay, now one more such dynamic example. A person is checking again and again, say hard credit score verification. So what actually it indicates to you? When I am taking more number of times I am trying to apply for hard credit verification, so it signals that he wants to take additional loan or he is very dire need of taking loan. The same case, you might have applied for loan at different banks. I mean, it shows he is very desperate to get loan. So beside considering as you said all these historical data, we have to look at these real time or streaming data also to predict the credit worthiness of an individual. Then when you are going to apply what you call these real time data, then your decision will be error minimized. Then how can you do that? Okay, so for that, so whatever the case which you are reading, we have some data set for that. I think by the time you might have received the data. Okay, you have received. So as it is, by the time you people might be knowing, Numan, just go and open Orange. By the time you people might have downloaded and try to upload. Otherwise, you can follow anyway. For next session, you are going to do what you call practicals. At least keep one laptop for team. At least. In every system they have Orange application got installed. Then it's wonderful. Yeah, we will do lab work. At least here we can explain about this case. Only not required you directly open, have you got downloaded? Yeah, one small change. What we will execute both the data set in lab only. So because some of you don't have laptop, let us do this. Let us complete our theoretical discussion here itself. So now this is one of the examples which I have discussed about what you call loan or credit worthiness. you try to think, the similar kind of way for even demand forecasting. So how can you make, we know historical data. Apart from historical data, what kind of streaming data you can use for demand forecasting? You are free to use your mobile phones. I'm saying typically. So you are free to use your mobile phone. You can search on your ChatGPT and you can always answer. I'm not going to restrict, what you call the technology which is available. Okay. So now tell me, so what sort of streaming data or real-time data may cause your demand forecasting? Yes, pardon? Bank interest, like? Okay, good. Family size. No, whether family size is a streaming kind of data, that I don't know. It is historical data, We are trying to, all of us know, for only one thing I thought of, I make you understand what is, historical data and what are streaming or real-time data. So now we will be discussing more on only real-time or streaming data. Online transactions. Social media activity. Website, clicks. Correct. Feeds. Inflation rate. Do you think inflation is very dynamic in its nature? Yeah. I am not saying that we are not undermining the relevance or importance of historical data. Besides historical data, so what are the other potential live or stream information that you have to incorporate in your model for accurate prediction? I am not saying that we should not use them at all. That is not my argument here. Besides, they are there. What is extra that you have to consider? As you said, rightly, social media activity. Sometimes, market trend. Yes. Have you seen any reviews of a specific product while making, your purchasing decision? I think it is dynamic data, The likes of a specific product may change from minute to minute, Okay. So that is your what you call, even we don't know exactly up to which stage you have to filter customer feedback, for any online product. At any time you may get feedback on your product, given product. So in a way, your feedback data, though it seems like it is an historical data, but for if the product is selling an online mode, so these feedbacks are being dynamic in its nature. It will be getting changed again and again. That is the reason why they are making your feedback score. The score is always dynamic, based on either your qualitative or quantitative input. Any other such potential live data or sim? Very good, correct. Which we don't expect actually. So that's why you have seen, stock market all of a sudden. Okay. Yes. Like what is my market analysis, ma'am? Say I am trying to help you out. The difference between ask and bid ratio, it is highly dynamic in its nature. So based on the differences between bid and ask, you can say that what is the demand for a specific script in the market. And next thing, credits, risk, that is something already default. Then fraud detection. So what are the streaming data? I told you are free to use your mobile phones. You can tell what are the streaming data or online data related to fraud detection. Credit card payments. This is really streaming. Yeah, any other real time data or streaming data related to fraud detection? Your withdrawal withdrawals is the streaming data. Okay, so mobile banking activities also streaming data. So why you can lively track, you can track it lively, and you can try to incorporate, say for example, your UPA transaction, though it is historical, but you can track it lively, and you can use those kind of variables in your prediction model. Yeah, hacking. Yeah, international fund transfers, cyber crimes. Yeah, correct. Correct. Now, at the time of predicting stock prices, so what may be like streaming, as he rightly said, we can sometime war, normally geopolitical risk, what you call broader terminology, financial financial quarterly results. Okay, so such kind of real time data you take and apply into your model. See, basically prediction model for any kind of tool is the basic fundamental same. Either we are going to use regression. Based on regression, you are going to do either clustering or classifications you are going to do. But at the time of creating your regression equation, so whether are you incorporating the live stream data or not in your data set for accurate prediction, that is the actual requirement which necessitate or mandate us to approach AI tools. So that what will happen, whatever happening in the market, say news for example, one of my student has done her PhD, so based on financial influencers are making some kind of video on a stock, how it is actually deriving into the share price. Okay, so whether it is deriving positively or negatively, how we can discount the influence on stock price. So what you can do, so on real time you can predict. Again, I am not saying 100%. The idea is we can improve the accuracy or model performance. And bankruptcy, so that is one kind of insolvency. So there is some interesting models, especially on bankruptcy prediction. Those who are doing research in finance, yes, yeah. So those who are doing in finance, you might be heard about this bankruptcy prediction models. The kind of figures which you are going to repeat in your annual statements, we can predict the chances of bankruptcy. the kind of say numbers you are going to repeat, there are certain advancements we can easily predict. Okay, so these are all highly dynamic in nature. Even when you are trying to look at all the financial reports of the organization, two things they prepare. One thing is standalone, and another one is as on today. So what is meant by as on today? From today to back 1 year. So don't you think that more of your financial reports are also becoming highly streaming in its nature? So gone the days, so where you have to take for the year ended balance sheets, or profit and loss account or cash flow statement, so that you calculate all the ratios. No, the same, I told you, two columns they are giving financial statements. One thing is historical and second thing is as on today, like back to 12 months. It is more of streaming. For tomorrow, you will get some other figure in the same right side column. So then, which will increase, say you are calculating ratio analysis for your classroom activity. Okay, those who are teaching especially financial accounting or financial, management accounting, you might be teaching the student ratio analysis, rather than teaching your, ratio analysis only with historical data. If you are going to take, see the streaming data of, financial analysis, then you are going to use. Don't you think that your model accuracy will become improved? You can predict ratios correctly, and accordingly you will make decisions within the organization. Correct? Yes, yes. Yes, yes. For any kind of ratios, that is my point. Rather than going, with past 3-2 years, let us take. You can use even dynamic statements also, so that every year you will get different data sets. The reason why I am discussing with you, please try to discuss these kind of topics in your classroom. You start very at low level. Over a period of time, you will also learn, then they will also learn. So we are also doing in the same way. We are starting slowly, learning, teaching. You will also do the same thing. And next thing is portfolio risk classification is, especially those who are Dhananjay sir said that he is teaching security analysis and portfolio management. What is the objective of investment, sir? Minimize the risk. So when you are make linear programming of your investment functions, so risk return optimization. So how we are going to so how to minimize the risk subject to constraints of so many constraints. Secondly, how to maximize returns subject to constraints. When you are taking these constraints, there should be not just simply static constraint. Try to ensure that you are going to consider some of the dynamic constraints. So then you can predict or you can prepare your better models. Now bear with me for the theory part. Once you are going to practice, then you will understand everything properly. Now this is about what you call about, or I no need to discuss, only now so far I think you have been attending almost this third day. Okay, could you tell what is classification, regression, clustering? Yes sir, next sir, good. You would just try to look at the very last portion of this slide. Okay. So when you are trying to look at our manual analysis means what I want to say, data analytics. I mean without any AI. Okay. So typically what we are going to do, so we try to formulate some kind of if else rules, if else. Okay. And here we are preparing regression, but these regressions are linear in its nature. But when you are trying to incorporate streaming data or real-time data in your data models, so your regression will be no more linear regression, which will become non-linear. Then when you are going to become say non-linear the data set into your model, then it will it will give results in a poor predictability. Okay. So otherwise we can do all these things like classification, regression, clustering in our manual type also. Not necessary that you have to use every time AI, but however the only thing is when you are trying to incorporate dynamic data or non-linear data, see data is not always like structured. It is highly, I would say, unstructured. The whatever the economy or major system which you have, data is unstructured. But what our linear is saying that the data should be structured, but on reality it is not structured. So that's why we are emulating the advantage of AI for predictions. Okay. Now how normally it will happen? This prediction in AI I am telling. Otherwise in manual also, but same, but in it is typically AI prediction kind of approach. So we collect data. I told in your historical approach or descriptive approach, your data collection is always structured format. But here different formats. Some of the data you might be having text data, some of you have contorted data, some of them you have audio data, video data. Sometimes you might be having any streaming data. I told your app tone, like the stroke tone, how rigorously you are typing letters on your loan application on any given fintech app. So that stroke is also matters. So now we are going to combine the different kind of data sets. So not only your historical data, but also real-time data plus streaming data. These both are same, real-time or streaming, right? And the format is not necessarily always quantitative. It can be even qualitative. Sometimes some of the customers might be giving. It is not always rating. Sometimes they may write something. It is bad or worst, or this is not working in your product. They will submit even what you call textual feedback also in any product. So when you are applying AI, so we are going to consider like different formats of data. So for prediction, it is not just only one set of data anymore. And next thing is data preparation. It is more of a cleaning process. I think you would have undergone some of the classes about new data preparation in the very first day or second day. Yesterday, yeah. So they will tell you how to prepare your data for for subsequent analysis. The same kind of procedure we are going to use here. And next thing is choosing learning algorithm. See now why we have to choose. So learning algorithm means, I told as a human we have certain what you call limitations, that may be in terms of bias, I would say, or so doing every time manual. Okay. So in order to avoid such kind of bias are repeating the same thing, manually. So we try to find out some kind of a learning algorithm with the help of this known as we call it as machine learning. So we try to take some kind of machine learning algorithm, and we create some model. We will train the model, okay, so that what will happen, by considering your historical data and as well as dynamic data, so it is going to predict you something, whether you have to accept the loan applications or not. So both the kind of information that you have with you, else financial information as well as non-financial information, as Subhasri used to tell always, non-financial information. So we may incorporate here non-financial information also. So it will improve accuracy of the prediction. And we will train that model, then we try to evaluate the model. So whenever new data is coming, we already train the data, it is trying to evaluate and it is going to predict the outcome. On every data, including data changes in our existing model, so it will predict some new thing. So this will happen like highly dynamic in nature, like real time. And see, most of the time, whenever you are opening any kind of app, you said that you got pre-approved loan of say 8 lakhs or 10 lakhs. How it works actually? How it works? Have you seen in your apps? Whenever you see in your app, you got a pre-approved loan of 8 lakhs. You can get within 15 seconds or less than 1 minute you can get loan. How will you get? What is the mechanism behind it? This is the mechanism. This is the mechanism for that. So means online streaming, they can track your every movement. They can track the kind of app which you are using for applying loan also, with your tone, with your typing speed. Then it will suggest you. It is not necessary that it is going to suggest for everybody same amount. It may be suggest somebody 10 lakhs, somebody 8 lakhs, or somebody say 5 lakhs, somebody 3 lakhs, pre-approved loans. Means so what this AI is helping, or how this AI helping the organization is, you no need to undergo any typical process of manual submission of application. They will consider all of your characteristics like this way, and they will suggest whatever the product will be suited based on your profile. Highly, so what you call, you are saying, so we are trying to clustering for this kind of people. This is the product is highly suitable. Like they cluster based on your profile total score. They suggest certain financial products. This is the way how the banks are working nowadays. In very near future, we may not find even, at least not now, at least down the line 20-30 years, you don't find even any what you call it physical branches. Down the line, for 30-40 years, we don't see any physical branch at all. Say now, have you seen the trend of closing ATMs across the different places? Now almost there is no ATMs, they are closing everywhere. So it is signaling us for using, we don't want anymore the physical cash, digital form. I mean, so we can do with UPI, you can do transaction. What is the need for cash? So down the line, we hardly visit nowadays for bank also. Do you visit bank frequently? No, I don't think so. Unless some kind of home loan or very big loan, we never visit it. Even if it is loan up to 10 lakh, I think for our profile, you will get always pre-approved loan on your app. You can simply click it, you will get within 1 minute, that too. So how they are offering within 1 minute loan? How they are offering? They would have conducted all these calculations on behalf of you well in advance. Now they are readily recommending products for you. Okay, so this way you can think of it. So how this AI model is going to helpful for industries and as well as a customer. Even as a customer myself also, I can see okay, if I want loan, Okay, so this is my pre-approved. And now, so I thought of, I will stop up to theory, then whatever the remaining we'll be doing, in your lab, computer lab. Now this time is, left for your doubt clarification. Or if you want to add anything which I missed to discuss here, you are most welcome to do that. My only idea is, so try to think about, so live data, streaming data that may potentially cause financial decisions, and incorporate in classroom discussions such kind of decisions, so that they can understand how organization works, or how, and as an individual, how I am getting recommended for a customized product based on my profile. Yeah, please. Sorry, I have forgotten to ask your brief profile here. Sorry. I will ask anyway. First, you ask your doubts.
So you started the lecture by saying that we have to remove the sentiments, emotions from our
Bias, yes.
when taking financial decisions, including stock broking apps and all. But when we employ or deploy AI in this, it is not giving the exact answer. First of all, RBI rules regulate the AI machine to not give any financial decisions. That is one. Even
Agreed,
if we ask
agreed.
for educational opinion regarding a particular share, most of the time the decision given by the AI doesn't hold good. It fails. What to do in such cases?
No, actually the same thing. Again, I am repeating. I am trying to use AI is one of the complementary tool, not the sole tool. See, when it is trying to solve you some of your problems of existing methodology, you can use. But it doesn't mean that you completely for time being. But over a period of time, sir, I told it is a machine. Now you are training. The more and more data will come to in your model. Now what will happen? The model will become more efficient. Then the predictive capacity will be automatically get increased. With lesser data, prediction capacity will be very minimum. It may lead you some kind of mistakes, as you said. But so when you are going to conduct this trial, say for 1 million observations, or say you have only, say for example, not even 10% of 1 million data, the prediction will be higher in the case of 1 million data set, not on like 10% of 1 million data, otherwise 0.1 million data. The more observations, then only it will lead to accuracy. But the point is, you use these things, besides you incorporate. Solely don't depend on only streaming also. You can use it as an extra, what you call a filter for decision making purpose. Yeah, any other doubt? Say, yeah. Yes. See, the same thing as of now. When you take the conventional prediction mechanism and AI prediction mechanism, it is being shown that it will increase the performance of 30% in some of the studies. It means normally in manual case it is going to give some result, but the accuracy of the result will be approximately 30% higher than that of your manual procedure, but not 100%. But which one you have to believe, which one you don't believe, means that is completely left with your own due diligence based on the company who is giving you such kind of data. Any other doubt? And the only motivation, why I'm taking this class is, when you are going to your classes, so try to make students to think in those dimensions also. Now our education system made them somehow all are only linear fashion, but the economy or the behavior is not linear. Then how to capture non-linear? It is very difficult in our conventional models. Then that is the reason why we depend on machines. For that we are using, see, this A is also machine only, we are depending on machine. That's all. So that without any prejudice and bias, it will take based on the data availability, it will try to suggest something. Say one thing, let me tell you one simple thing. As you know, you said that you are teaching stock market operations. Assume you are doing some kind of trading or an investment. So in AI, normally when you are adapting algo trading, what will happen? You are going to pre-decide the entry price, exit price, and as well as stop loss price. Without this information, you can't enter into the order process on any algo trading app or algo trading. But when you are going to do the same thing on manually, without what you call stop loss also, you can place your order. Both are same. Why we are not placing order means you have certain kind of bias, but machine, no emotions, no feelings. You have fixed some stop loss, you fixed some entry price, you fixed some exit price, it will automatically execute what may come. But as a human being, what will think? We always greedy, that is one of the bias. And it is slightly going here, let me wait. Let me wait, let me wait, let me wait. Okay, that is one. Once it started falling, we never exit immediately. We say that no, it will again rise, then wait. So what we are going to? We are going to face unlimited losses in this process. Why actually happens? Both the process is same. Here also we are placing order with the help of algo trading. In manual also we are placing order. Both are executed on exchange only. Yes, true. In both the way, price is also same. But why one person is making say complete loss, another one is making at least a decent amount of profit? Because of portfolio management, machine is taking decision without any emotion. It doesn't.
Even when it's low, the price suddenly rises. So that's why these people of these days they are recommending selling on highs. Instead of selling all our stock at once, we have to sell them phase wise.
See, actually, what I strongly feel, sir, even if I am suggesting something, if you are taking into the consideration, still it is biased. I might be having some kind of residues. Why I am recommending so and so stock? The same thing, you are also carrying out, without verifying. You simply listening whatever I am saying, then you are executing. Both are biased, The idea is in investment decisions, especially related to stock market, possible extent we try to reduce or avoid these kind of bias. See, discipline, persistent, patience will create wealth. It is not sudden one day rise or one day fall will create any difference. It is only always consistency in your discipline. That's all. If you have consistency, if you have discipline, though you don't use, say for example AI. So why we are using AI means to discipline ourselves. Without emotion, it will take decision. That true, sir. That is true. The same thing. At least for finance, you excuse this clause. Yes, that is the reason what we do. We try to nudge to overcome certain bias of the investor. True. That is true. So why? the behaviors are not always linear, it is non-linear. Yes. See, when your personal profile is different, then automatically you can generate some non-random data only now. Then how would you expect accurate predictivity? It is not possible. Yeah, anything? Yes, if you have any doubts. Yeah, please go ahead. I know, see, I know very well Telugu. I am from Tirupati, Andhra Pradesh. మీరు నిరభ్యంతరంగా తెలుగు మాట్లాడచ్చు. కాకపోతే మాది పుష్ప తెలుగులా ఉంటుందండి. దట్ యూ హ్యావ్ టు బేర్. కరెక్ట్. Of course. Otherwise, what happened, see, what is happening, when you are trying to use, any fintech, related applications, sometime, they will conduct some kind of preliminary survey. They will, ask you, kindly give, answer these questions or fill this, kind of thing. Through this, they can measure your literacy. In fact, we have also conducted one research. If you go to my profile, you can check, we try to measure financial literacy with the help of gaming. So we will ask some of the participants to play some game. Through that you can measure what is the level of their financial literacy. Sir, it is better, say, what you can see for time being, you try to use any open source, models actually. See, when you are using, econometric, predictions, especially for stock kind of thing, it is always you can use, UViews. It is for a limited trial version you can get these kinds of things. And the kind of softwares which we use for, survey data, like, is different here, it will different. So that we can assemble again in lab. Okay, see you.
You personally invest.
Yes.
కాస్ట్ అకౌంటింగ్ బడ్జెటింగ్ కి మనం ఏ విధంగా ప్రొజెక్షన్స్ అన్ని వచ్చాయి కదా which department are you? Sir, I'm business school. కూర్చోతున్నా పక్కన అయితే అంటే అక్కడ ఉన్నారు కుర్రోడు మళ్ళీ మీరు మీ మాతో పాటు తిరిగారు అందుకని అదే ఛాన్స్ అనుకోని ఒక్క అబ్బాయి వచ్చాడు ఒక్క అబ్బాయి
service track because Python we need to store.
Then let us start. So now can I open Orange? It is already there. You have downloaded?
Orange is
What you can do now? I have
some
yes. Like no, I have prepared any step by step. I have prepared anything.
okay. So look at in PPT. Please load the file set. What you practically will able
No, so otherwise these are the step by step.
write the step by step. They can understand. You need to show.
Yeah, I think we'll try to start. See, we have written step by step in this slide actually. That means which step first one, second one, third one, and so on. And this PPT will be shared with you through organization. Okay, don't worry. So just now try to observe. So how we are trying to implement. So AI model, especially for the purpose of predicting so known keys. Okay. So take your second case which I discussed in the classroom. So for the second case, we have certain data sets. If you want to read once again, just read it. No.
Can I see from that class?
Yeah. Yeah, so as I told we have step by step in this slide, and it will be distributed to you. Just whenever you have free time, what you can do, you try to implement those steps. That's all. Okay. So now, so my PhD is student is going to demonstrate how we are going to enter onto the platform and how to so use. Yes, yes. So all of you please, yes. All of you please download your data set that has been shared in WhatsApp. That in data set file you have been shared the two files. First open the file related to load that. Whether it is first file or second file, which I don't know exactly. Credit risk. Credit risk file. Woman, can you please open data once?
Yeah.
So that they will validate. This kind of data set. Yes. The file. The file name is credit risk data set.
Okay.
Yeah, everybody please try to open this file called credit risk data set. Now we are trying to demonstrate the procedure of using Orange platform. Yes.
using this data to perform.
Wait. First use this file. Print this data. No, if you are not downloaded, orange on your desktop, it is better don't waste your time. Use it along with the people who are already there. Otherwise, it will consume another time. At least 10 minutes. Yes, sir.
It is present in almost all the laptops or desktops.
And the same thing applies. Otherwise, try to change the system in which you are operating. Like, don't change your seat.
So orange is not opening.
Not opening.
And I can't do my documents.
You open,
I don't know why this.
No, it's okay. Yeah, we are trying to do the same. We are trying to laptop.
Yeah, there is a data is there, or I'll do this.
Connect,
Okay.
Need any help of Archana? For this it is okay. Now, so try to ensure. See, read one by one. Don't be so hurried. They don't.
Please open the orange.
So try to open your RF like this. So ensure you have the screen on your desktop. Yes. So if you do not have, please raise your hand. ఇదేలా మీ desktop లో ఉందండి? అందరికీ ఉందా? Done. Next.
So first we need to load the data, the credit data. We already shared the data. For that you need to click in file. Everyone please click in the file.
So that file is already here, Yes.
And double click in the file. Okay, you can search here. Hello. We already shared the data, credits data set. Please load that data. Wherever you saved that data, please load it.
So in our case, it is a download. In our case, take it into download and your desktop wherever it is there. Just download and try to upload on your RF platform. So the file name is credit risk data set.
Actually, now we are working on the. Okay. Which one? The file.
Already the data is being shared with you. What you can do, you send it to your mail, download. Then after downloading, try to click on this file. On this icon, it will come on your working sheet by right side. When you are going to double click, then it will show you this window. On this window, so you try to open, it will show you where actually you have saved. See, like this it will show. So in this case, it is in downloads. So you select the file. So this credit risk data file. Okay. Everybody got selected file on your platform? Yes, sir. Yeah, fine. Next.
So now we need to fix targets.
Use.
Hello. After loading data, we can see the items.
So these are the
Variables. Person age, person income, like that we can see. In there is loan status.
I told you this data can be combined. So some of them are see linear data, non-linear data.
And in your system, maybe it's future. We need to change that target. Click the futures and make it target because we are going to predict, analyze that thing.
So what is our target? Whether to sanction the loan or not to sanction the loan. I told we always, so we try to conduct manually. The due diligence process of any loan is, so not to sanction the loan. If I fail not to sanction the loan, then I will get loan.
So just apply after that. And close the window.
Up to this, have you done? Everybody? Future set future లో మీ లోన్ స్టేటస్ ని టార్గెట్ చేయండి రైట్ సైడ్ క్లిక్ చేసి దాని టార్గెట్ చేసుకోండి
Actually, here we can see the loan status. In here maybe some data future. Just click the future, then make it a target. Just click the target. It's not going to, not getting. You guys downloaded the credit disk data set. Then after that we will get these categories, names.
show them how to get this.
Yeah, only we need to change loan status.
What do you want to predict? That you are here, what you are going to select?
That is our target.
You are going to sanction the loan or not? Are you okay with Telugu?
No.
This
So-
is our loss. I mean, this is our target.
So just apply. After that you can close this. Next is,
Now, have you done up to this step?
now we can visible the data. For that just drag like this and just search data table. Data table.
You can find data table option.
And double click, you can see the data.
If you double click on data table, you will get a pop-up data table like this. Everybody can see this? Yes, sir. Huh? Yes, sir. Yeah, you assist. You assist.
Just drag from file and search data table. Or you can see the left side there is lot of options. Left side the lot of option. You can search data. Means no.
Have you prepared this data table?
Okay.
So those who are not following, we will come back to you for second or don't worry. Just next one.
After that again you guys okay from there. Okay. Again you can drag and search test and score. You need to search test and score. Test and score.
This test and score is one of the variables.
Then just search it. Now we are using logic regression. You know what is logic regression? For
Zeros are ones. It means
For category-
say if home sanction, say 1. Not sanctioned, 0.
so categorical data we using logic regression. For that from test. Okay.
Do you know what is meant by categorical data? So when you have, say, on your questionnaire, say the Likert scale items might be having different points. Like say for example, strongly disagree, neutral, agree, strongly. This is the category. Or age, you might be having different age strata. Or income, you might be having different income strata. Or even say gender. So these are all known as categorical data. When you are trying to look at the categorical data, it is always advisable to predict with the help of logic regression. When it is quantitative data and use data, then you will use some different approaches.
So shall we start logistic?
ROL.
Like that, you can drag from test and score and search logistic regression.
See, very first one is logistic regression. Logistic. Binary.
Yeah. You can find the items the left side also. You can select. You can select and drag also. Otherwise, you can directly drag and search. And we can use another item also.
It is learning. It is trying to understand the pattern and trying to understand, the process. I have shown in Excel, in PPT some steps. Those steps we are trying to execute here.
And we can do another analysis, tree, random forest like that. For that, like this, from test and score, we can drag and search a tree. We'll explain later. And the forest.
I will tell you. You follow this procedure.
Yeah, random forest we can search.
Yes. So 1 minute. So what is meant by there is one famous saying, random forest walk. So random forest walk means though individually you are going to walk in a different pattern, but your entry, starting point or reaching point may be more or less same. We wanted to follow some crowd. And simply I will tell you, though it is some different example, but don't think otherwise. You assume some drunken person, we use it to look at at a bar or some wine shop. Okay? Assume there are different drunken persons. Okay? There is say bar, assume it is a main road, then he has to cross the road, then he will come to that side, then go for food. Okay? When he is starting from bar, so what kind of pattern he will follow to reach that side? Assume it is in Hyderabad. Each and every individual will follow different pattern. If you imagine, so once he is done, then he is starting road, he has to cross this road to go that side. The similar kind of trend when you are going after for crowd. Okay, so therefore, though they are going to come in a different pattern, say one person may come like this, then like this, then like this, different pattern. But at the end, what is going to from wherever starting and reaching, they will reach. Okay, so this is some kind of pattern which you can observe in the data set. And another kind of thing is assume a drunken say husband with his wife not drunken for example.
So
Yes. Okay, so in this case, how they together work? So assume she is accompanying me. He is helping him to cross the road. So the walking trend of both this drunken husband and this good lady, for example. I am not saying that those who are thinking bad, but in general example. Okay, an example. Then their pattern of walking will be different. But their starting point or reaching point will be same. Then imagine the husband is drunken and wife is also drunken. It follows some kind of pattern. Clear? Now, three friends are drunken. Then their pattern, see, each and every friend will be walking in a different direction. But at the end, they will try to reach the destination. Another side of the road. So, this actually indicates, what actually indicates, though this starting point and ending point is common, the kind of movements are different across the different data set, across different observations. Okay, so those patterns are known as random forest. See, in a forest, randomly we are walking, but what is our goal? Just out of it. Each and everybody will be trying their own route, and they will try to come out. So how machine will identify this? based on the trend that is being created within the data. How it is actually, working. How it is moving in direction.
Actually, the test and score is running. It will take some more time for load the data.
Yeah. So this we can show, it is, now predicting. Correct. So, are you getting any like tests for running kind of this symbol?
Yeah.
Okay, then fine. Those are not.
Because my laptop is slow, maybe that's okay. Before loading this thing, why we are using AI? Why we are using AI? What is the purpose of using AI? No. To make our work easy. So this is a AI software. So we are using this. Normally, how we'll do this analysis? R square. For that we need coding and everything. But here just click. We are getting regression, logistics regression.
No coding, nothing. If you are going to run these things, in any software, it will be consumed for manual time. Yes. But here, no coding language required, though you are from finance, commerce, marketing. So we get
Plug and play kind of thing.
kind of. Now, no more it is, coding is required. Or no more, computer science has any privilege to make understand at least the AI. Even he can achieve. Everybody, you get your streaming.
Then you can double click in test and score. You will see the logic regression tree, random forest variables. Now mine is loading. That's why.
That is also.
Now you can see logic regression tree for the values. We'll explain the values later. These are the values. Now without any coding, anything, we go to the logistic regression values. Now from test and score, we can drag to confusion matrix. From test and score, you can search it confusion matrix. This one. Matrix. Okay. Just double click it. Now you will get the predicted values and actual values. 0 is non-default. 1 is default. So we'll explain this thing later. And again you can connect scatter plot from confusion matrix plot. If you double click in there, you are getting the y-axis. Is there any data available in your? Because 1 minute. No, confusion. Yeah, before that we need to connect this confusion matrix. Yeah, data set file. Now everyone go to confusion matrix. Now from file we need to connect to confusion matrix. I don't know why it's not connecting. You it's not. You can connect now. No. Sorry. Test and score we need to confusion matrix. Okay, then we are searching here scatter plot. Scatter plot. Then from file we need to connect to scatter plot. Okay. Then confusion matrix also connected to scatter plot. Now double click in the scatter plot, you will get the data. And the x-axis you can select income. Income, person income. Sorry. Y-axis. Sorry, 1 minute. No, x-axis is
This node status for white.
File to confusion matrix. Confusion matrix to scatter plot. One file to scatter plot.
actually you can whatever variable you want you can connect it based on changing the x-axis and y-axis. Like that we can do. If you want to x-axis one person's person income and y-axis you want to loan grade indent, like that we can change the scatter diagrams. And after the test and score, if we want data table, we can connect to confusion matrix and we'll get a data table here. Data table. Yeah. I don't know, it's not loading. It's loading now. I'll show you the model. This is the model. Confusion matrix to scatter plot. From file we need to directly connect it to scatter plot. And confusion matrix to data table will visible the data. So this is the model for this analysis. Now we'll click the test and score. We'll get a logistic regression tree and random forest values. And here we'll get a confusion matrix. This is the value. Now we can okay.
Scatter plot is not working.
Scatter plot also working. It's working. Sorry. Scatter plot is working, and if you click the loan status you will get the color also. In attributes, in color, you can, if you select the loan statistics, you will get the color. This is the result we are getting. Using this result, we are evaluating. Okay. Now we go to the logistic regression and everything without that not visible. I don't know, some technical error will be there. And after all, the whatever AI tool and everything, we can learn ourselves by exploring. Okay. So you try to explore after this. Now we can go what all are these things. If the logistic regression we get in between, the value will get in 0 and 1. And whatever AOU, area under curve, this we saw these things here now. After all, we are doing 1 minute. After all, we are doing a sample data. Based on sample data, we are just getting know how to do using this. So after getting this analysis, we are checking. We'll get AUC, CAF1 the values. Okay. What is these values actually? If the values above 0.8 is a good, we can accept the loan. We are searching the loan status is whether we can accept give him loan or not. So based on after we are doing this, we got this value. Is all are 80%. This MCC above 60 is good. Other all values are 80 above 80. So we can give is a good model.
When we are going to see that this model is predicting accurately. When you are going to do similar kind of data for any flow applicants, so whatever it is going to generate the score, based on that, you can say that your loan got sanctioned or not.
This is same for logistic regression tree, random forestry. Above 80 is very good. Above 90 is excellent. Like that we can say. And I'll show you the confusion matrix. We already go to confusion matrix here. This one is the confusion matrix, the value. In confusion matrix, what is actually confusion matrix? Okay. This is predicted. This is also predicted. This is actual. Whatever value we have. Then we approved this much of number 20,091. We can approve a good customer as a good customer. That is showing the predicted. That is showing this confusion metric, and this also this we got a risky borrower. This fall dangerous, and this also false alarm. Whatever. Actually, we go to confusion matrix. I am saying, just look at the confusion metric table. The same table we got in the values. This value here, just look at this. The predicted, paid, and actual. This value correct we can accept. They are good customers. The numbers came this column also we can, but this false negative you show now, that is very dangerous because they are not going to repay the loan. That is the. So here while opening our result, we can see 1,601. These people are not going to repay. Actually, who need to go we need to pay the loan or not? That's we are checking. So after we go to the confusion metric, we understood this number of people we can give loan. This number of people we can, because they are non-default, already default. These people are non-default. Okay. So that is our first credit data analysis. This is just we showing how to do AI tool without any coding or nothing. Just we upload the data, just drag, we go to the result based on we analysis. This number of people we can go, and the model is very good because 80% logistic. Okay, sir. So this is the classification, whether we can give or not, yes or no for this answer. We completed this section. Now we can go to the regression section. So, which one? Test and score. Yeah, it's because of the data not loaded properly. Because yeah, you can export this thing after the class while you get in the free time. You can explore how to. This is just showing the model how to load the data and file and test and score. Which paper?
No, actually, then wait. We'll try to come line by line.
Better go, attempt the questions. Okay, sir.
Okay, that's good. That's correct.
Some system will work, some will miss, some will load. The problem is the loading the laptop. Some small error make the problem. The problem is before loading the test and score, you connected with the confusion metric. Because of that only you are not getting confusion metrics. What you can do, delete the confusion metric. After loading test and score, you can again connect to the test confusion metric.
ఫస్ట్ కంప్యూటర్ మ్యాట్రిక్స్ కనెక్ట్ చేసేయండి.
No, it is there in PPT.
In the PPT?
We will be sharing this PPT with them. They are step by step procedure. This is.
Should have gone through earlier.
కన్ఫ్యూజింగ్ మ్యాట్రిక్స్ తర్వాత డేటా టేబుల్ కాకుండా ఫస్ట్ డేటా టేబుల్ కరెక్ట్ చెయ్యి తర్వాత వాళ్ళు చెప్పిన ఆర్డర్లోనే పోతే ఆర్డర్ పోతే మాత్రం
నిజానికి కన్ఫ్యూజన్ వస్తుంది. Say if you follow strictly this order, certainly you will get. There is no chance that you are not going to get. Yes. You have ఎవరికైతే తక్కువ
Whoever not getting, just remember after loading file, you need to set the loan status as a target, because that we are not to go into predict. Okay. Then after that only we'll connect a test and score. After loading test completed loading, then only you need to connect a confusion metric, otherwise it won't come. Okay, so this is the classification. Okay, we already did the interpretation. Whether we need, okay. We already got the test and score. So we said logistic regression above 80 is a good model. Actually, this model built by AI. We are checking the model built by AI is correct or not. That is this AUCA area under curve classification accuracy. This checking the model is correct or not. If model is correct, above, actually logistic regression we set default 1, non-default 0, the values. The logistic regression value near to 0 is a good, near to 1 is default, means bad, risky one. But here we are testing the model. The AI developed itself a model. The model is above 80% or 0.8 is a good model. So the model we got it here is a good model. So
See, the idea is you have given some kind of data. So how far this prediction is better. So up to 80%
yeah,
your model will be estimated if you are
based on this AI tool, this model is very good. So after that, we saw the confusion matrix. Confusion matrix. The confusion metric. This is the predicted one. This is the actual one. 0 means default. And 0 means non-default. 1 means default. Default means not good, risky one. Because people are not going to pay. And 1 means good one. So, 0 is good. 0 is good one. Sorry, 0 is good one. So based on that, I show you the how we can say is acceptable or not. This one, the number came this column means predicted and actual paid. 0 0 is a good one. 0 0 is good one, and this 1 and 1 also positive. Because 0 0 also positive, 1 1 also positive. The negative predicts false. 1 and 0 and 0 and 1. These are negative. So that is a dangerous one. They are not going to pay. While we checking total, we assumed 32,050 581 data persons data we checked. In that we can accept 20 and this data also 5,000 we can, some terms we can accept, not that much good, but this is good one, 20,000 something, and this is the dangerous one. No, this is the dangerous one, 4,001. The red color is the dangerous one, 4,000 something.
See now normally fintech companies will do like
Yeah.
up to this 20,000, they try to create rigorous sales activity. Like a rigorous sales, whenever going to say, buy this, take this, make a sale phone call, like different kind of thing. But once they have reached the threshold target of sales, for next level of this 5,000 is it will be like automated sales activity. That way it was to pre-approved. Though you are not going to pay, it doesn't going to hamper their turnover. But however, so even if you are going to 50% of sales are going to converted, so from this another segment, that is better. They don't do forceful sales activity and another segment, only recommended activity. So those, for example, you got pre-approved loan. How many of you have avoided in this class? For example, on any app you might have seen, you got pre-approved loan or pre-approved credit card, etc. How many have actually taken based on those recommendations? In fact, they also want all should not take. So that it will reduce their default. Only recommend. For them, again, if at all they want to put some more filters, by any streaming data or live data, they will incorporate to assess for that. Based on that, the rate of interest may be varied out. Not necessary that they are going to give the same interest rate for all the customers. Sometimes you might have heard that, sir, based on your credit score, credit card score, CIBIL score, you are going to get some reduction, in what you call interest rate. Some of them might be getting loan at different interest. So how they are doing all those things? So with the help of this confusion matrix score.
Okay, sir.
Now just we are looking at more from banking point of view, financial institution point of view, how they are using our information to make decisions.
Yeah, now we completed the classification part. Now we moving on to the regression part.
Now they have classified who are going to definitely say pay. Some of them are second level and next two levels are no, rejected. We have classified. So you got say assume you have some financial service organization You are getting on daily basis thousands of loan applications. Can you manually take a decision on all 1,000 loan applications? But with this, what you are going to do, when you are going to feed those data in that Excel, when you are collecting, correcting to on this AI tool, this AI, is giving recommendation to all those applicants. So to whom you are going to declare, to whom you should not. If it is going to come, say for example, recommended, you are going to pay. And other one is that rejected. That's very next moment they can take a decision. Once you submitted application, instantly they will take a decision. Otherwise, which is very difficult in conventional process of loan sanction.
Now we are going work on for regression, we are going work on the stock data. For that, you guys need to load. First, open the orange again.
You have second data set with you,
Yeah. For that, go to file and you can open new orange. Because we are working on regression. Earlier we classification. Now open the new one. So you will get a new orange. And again go to the file. And here we are going to load the Nifty. Okay.
some gap.
Okay. File, everyone we need to load Nifty 50. That data you can load.
You got this file? Yeah, please you can use this.
Here the close is target. Everyone loaded or not? Actually, Nifty 50. We already shared that data, the Nifty 50 data. You need to upload. Okay. Now after uploading, what we are going to predict? Closing value. For that, you need to put close as a target.
Why not predict the closing value? So when you are going to make the same, for example, buy or sell, it is based on closing price of the share. That's why you are putting target as your closing price. The way how we done in the case, whether sanction or not to sanction. Okay, in a similar case, what is your closing price?
Now you can close that, and again we are going to.
All of you have uploaded your Nifty on this new file. And I will set target after the closing price. If not, you can call it the process case.
Yeah.
So target. Done?
The back side. Done.
Yes. Next.
Then you can again go to test and score.
Test and score.
Okay.
Test and score. Yes.
From test and score, you can connect it to linear regression.
Linear.
This one, linear regression. Linear regression. We are going to predict. Normally, for what purpose we are using regression? For prediction only. So,
Predict. Say stop price.
close price. Okay. So just double click the linear regression. So the test and score is running. Now you can click the test and score. You will get the regression value.
Whether are you getting this linear regression score on your system? Just check. You are getting any value like this?
We can come to analysis part later. We can do first the next you can see the data table here again. Just drag and select data table. Okay. You will see the close price, date and everything.
Stock data.
Everyone completed this step. Test and score. The file is loaded or not? Who said that? I think that system have some problem. No, backside. As target. From there, you can connect it to test and score. From test and score, you can connect to linear regression. Then you can, while after loading, if you click the test and score, you can see the linear regression values. Here also we'll come to this analysis. You have a doubt why it's not 0.8 or something. This is a big number. We'll come to that. And after that, if you want to see the data table, you can just click the data table, or there is no need for that. If you want to see, you can go. Okay. From linear regression, you can connect it to prediction. Before that, I'll tell you, we already shared one more data is for share prediction. I just opening that. You don't need to open, just look at the screen. There is one data I already shared. It's 1 minute. This data I created manually. So up to 16 April 24 the data is there. The file we already loaded in there. Then after the dates, if we give to open, high, low, then what will be the close price? That's we are going to predict. Okay. So for that I created the manually. So we'll get that data. So for that purpose, first you need to connect this one, linear regression, from linear regression to prediction. Okay. Then here you can double click or left click. You can CSV file import. Anywhere in the screen, you can click right click. Yeah, I already sent it. Yeah, I already sent it. You guys, I already sent it this file, the created one CSV. So for that, you can click the CSV file. Everyone is here. Prediction. Uploading. Yeah. So just click the CSV file and double click the CSV file and upload here. It's normal process only, you can upload. And for that you need to upload for share price prediction. For share price, there is a file. Is manually created. We are predicting in this date what is the closing price. Okay, just open that. Yeah, just open that. Yeah, here you can see close price in a question mark. We are going to predict that. Okay, for that you need to connect predictor to this CSV file. Sorry. I don't know why it is not connecting. From prediction to CSV file you can connect. Okay. After that you can click the prediction. Wait, it need to load or something. Yeah. There is a linear regression value will be there. One new column added linear regression or something. Is it here? There?
Now you will close our empty and we have figures. Question mark. Question mark. Okay.
No, there is in front there is one linear regression there is. Can you see it? Yeah. 1 minute, mine is not loading. Yeah. Yeah, you can see after uploading, you can see 5 rows, 7 features that you saw now. Then you can reload. Now you can click the prediction. Okay. No, in prediction it will come linear regression. 1 minute. Table.
It is not for CSV option.
Yeah, just write it and collect it.
CSV file is not open.
No, it is showing CSV file input. In some of the systems, CSV file input option is not.
Okay. It will be there. 1 minute, I'll come.
It's
We need to Excel, make extension like that.
CSV folder is not there. Like CSV options are not there. MS
No, you are getting Excel sheet otherwise.
Excel.
Before that, I'll show you one thing. From the test and score, you can drag and open the data table. In the data table, we can see the linear regression. This is the predicted value in this day, and here the close value will be there. No, this is the linear close value. This is the actual value. This is the predicted value based on the data we uploaded. Each day, actually, the predicted value 1777, but the close value 177 is the actual value. Okay, that we can see from here. After linear regression, I don't know why. Yeah, you need to connect a test and score to prediction also. Okay.
Connect from test score to prediction. From test score to prediction.
Then you will get to the linear regression. Okay, this is the predicted score. We already gave the date. In that date, what is the predicted closing score?
Both the things. This is actual closing price. This is predicted closing price. I told you, but very closely we will, So how we can create more activities? When you are going to consider the data, like I told different kinds of data set, like it is static data, railway data, hybrid data. So when you are going to incorporate such kind of data set, your prediction become closer to reality.
Again, I tell you, the online AI tools, whatever the software, we can't learn without exploring. We need to sit and explore. We'll learn new things. I am also in a learning process, not an expert or something. So this is just a model how to do it. Basic things. After this, you need to go and explore. Open the Orange app. Try with the different files. You will become expert like this. Okay. Now we are moving to analysis part. Now I already said we can see while we check in the 1 minute. Random for logistic regression. Here test and score. We can see 19,059 point something. So earlier we said if the model is very good, we need to above 0.80 or 80%. Here in the case, what happened? We are around in Nifty currently around 22,000 plus are there, the companies and this thing. So here we got how many points we can calculate at a point. Here RMC is 44 point. So divide 44 into 20,000, we will get that percentage. Here around 0.2% or something. Like that we can predict. So 0.2% error only there. So how, and we can R square. If the R square is 1 is perfect, near to 1 is, we can say is good model. Here the R square is 0.99. So the model is good, we can assume like that we can. So using this, we already predicted the stock prices. This test and score, we are just checking the model is good or not. Based on that, we already predicted. Here we can data table the all the predicted value we already got. I don't know why this loading. Earlier it was loading data table. You saw the linear regression and closing value. That is predicted value. The same, using the same data, we got the predicted value. After that, we did manually without closing data. Next date, what will be the closing value? Here we got that. The linear value we got here. So like this, we predicted the regression. That is the regression part. After all, you will get a model like this. So, sir, we can move next section, clustering. Yeah, next we are, now we did the classification and regression. Now we are moving to clustering. For that, we are using customer segmentation.
So whom we have to give loan, to whom we should not give. And if at all we want to give next segment of person to whom we can recommend. It is not for selling, to recommend. Okay? So this way we have done classification. And next thing is prediction. We have predicted future share prices. No shares in the top of this one. Now segmentation. Otherwise we don't have to do clustering. Classification, regression, and clustering.
For this we are going to use the customer segmentation. For that we again need to open a new file. Open the Orange, go to file and new window. We are opening new window.
There are some file for the customer segmentation, Excel file.
Yeah, we shared a file. So select the file, load the file. This file, customer segmentation.
what should be the target?
Yeah, I'll tell you. In this case, we don't have any target value for clustering because we are clustering these things. We are clustering only cluster 1, cluster 2, cluster. We don't have any target data. We are clustering. So for that, we need to make some changes. Here, the ID you can make a meta because we are not going using that. It's just a meta. ID is their number, customer's number only. We don't need, we are not using that for any analysis. Yeah, that make meta. And response also you can make meta or skip. Yeah. Yeah. Response meta, that also meta. And then apply. Then you can close that. Then from file, drag the data table. You will see the data table also. Okay, the uploaded data table you can see.
Have I uploaded table and data? No.
Everyone here? This? Okay. From there you can drag it to the k-means. This one, k-means. Here for clustering we'll use k-means. Yeah. Just select the k-means.
K mean.
It's loading. We'll wait for some time for the loading. Okay. From there we can connect to the data table also. You can see the data table. Here we using box plot. Now you guys almost aware about this, how to drag this thing. We can easily move on. Just from the comments you can come to the box plot. Yeah. And scatter plot also. Yeah. This all based on your need. Okay. Yeah. COT plus plot. From K means whatever, there is lot of items here. Based on your needs, you can select. In linear regression also, whatever analysis you guys want, you can select. Okay. That like that will open the scatter plot. In the scatter plot, here we can select income. X-axis income. Double click in this once again. You can double click the scatter plot. Okay. X-axis income, Y-axis MNT wins, that thing. Wins. Wines. And color cluster. MNT wines. Color you can select cluster. Now you can see the different type of cluster 1, cluster 2, cluster 3. This is the chart of the clustering, different type of clustering. And like that you can click the box plot also. Here you can see the different clusters, cluster 1, cluster 2, cluster 3. Yeah, because why 3 cluster? Here K means we selected 3 cluster. While clicking cluster, you can use sometimes in between, but why which one is coming the higher value? I'll show you. If we select from the 2 to 5, here the cell hotel scores. This scores, based on this scores, which one is higher? 0.272, and that you can select here. Normally 3 will get it, and we can make it a 3 cluster. If you want more cluster, you can do like that. So like this is the clustering thing, this part only. So by this we completed 3. In 1 minute, sir. In clustering also the analysis like this. Okay, scatter plot, box plot, something. So now we completed the classification, regression, and clustering. So there is lot of items we are using the AI tool for making our job easy. So like mobile phone, you can learn yourself by opening the app, exploring the items, whatever so we showed here the basic of regression, classification, and clustering. So this is which one? You can double click that in the here yeah in between 0, 5 and 5 the chart is in between. Okay, so this is the model we can do. Yeah, this much is the practical section.
When you try to take into these 3 aspects, like classification, so regression and clustering, you can use it for different finance teaching applications in your classroom. Okay, so only thing is what you need. You need certain kind of data set. I think you might have heard certain classes, very beginning classes. I know what are the different data sets, like Kaggle, you see, kind of there are some open source. Even R&D also, you can find some refined data sets. Okay, so you can use those open data source on different topics. Then you can conduct activities or the classes on this application. So one thing is say when you take classification, you can classify. So the customer, even in your typical classroom interactions also you can do that. So who are the good customers, are most likely will become better customers or no bad. Okay, and you can do these applications in different subjects when you are going to teach. So this classification problem in your entrepreneurship course, you can teach them. So who are the repeated customers and who are the one-time customers? Okay, so this kind of classifications we can make with the help of this. Okay, and especially in finance, in financial management. So bankruptcy predictions, not only for individual loan application, but also companies can do this due diligence process with the help of a tool. So for institutions also, if any institution is is submitting an application, so they can take like a decision with no time. I think you heard sometime I heard news. I mean some ad like in Muthoot you will get gold loan with 1 message. Within 1 minute, they will give you 1 minute. Imagine, sir, how they are giving, this actually 1 minute loan based on, AI register. So the moment you are going to add certain details of you, it will capture, some of the data from you through your PAN card. It will access almost all of your data. PAN card. Yes. Okay. So if they have no access to get some kind of APIs on app, your tone also they can get, like stroke tone, like different kinds of things. They can get within few seconds. Within 1 minute, they can take a decision whether to give you or not to give you. Right? Any kind of bankruptcy prediction. And what is the likelihood if you are going to continue your business in the same way? What is the likelihood of bankruptcy that you are going to face? We can, but see, when you are teaching, SME especially, when you are going to take, SME data set or financial reports. So some of you are saying, that score you can use for measuring financial health or financial prediction. Okay, so if you apply, you can say what are all the SMEs are going to get success and what are the other is going to face failures. So once you come to know it more in advance that these are going to face a likelihood failure, so you can avoid sanctioning loan to some kind of an SME. Otherwise, it will create huge NPA to the banking organization. This is another application which you can make with this. Next, start written prediction as it is. So when you are going to incorporate, so not only quantitative but also qualitative or written information, you can exactly predict your portfolio returns. In bank, even in EAG scores also, I think you might have heard. There are many people are started to thinking about EAG. The idea is environment, social, and governance of the organization. Okay, so when you have what are the financial as well as non-financial information that may cause your EAG, and you can classify according to all these classifications. Likewise, there are n number of finance applications which you can teach with the help of RHA2 by just taking some data set. If you could teach only these three things, that is so classifying, regression, and clustering, that is alone sufficient for any financial situation. Now, the case studies, it has been given to you 2 case studies. So the same thing, it has done. If you carefully read all those, if you solve all the concepts of those case studies, you can complete all these 3 concepts. Like classification, regression. So this is I thought of to discuss with you people about how you can execute. If you have any doubts, still you can ask. And only one thing is, please, though I can understand it is very new phenomena to everybody, not only you. So all of us, we are learning things. So the more you practice, you will understand. The more you practice. If you are not getting this, it doesn't mean that it is so difficult. This is the most easiest one. See, without the coding, can you imagine you can take a decision without coding? Now only drag and drag options, why we are doing this and the synthesis we have to have. Otherwise, if you want to manually execute through coding, it will take days together. So that's why my sincere request is, please practice it as much as you can. Read it again and again. And same, you can use that is the reason why we shared this data set is the same data set you go on using your colleagues. You don't need to search for any other review. Same thing you use. Until you become expert, you use, then later you can change data set or scenario different. You can.
But if we want to calculate the highest or lowest of a particular share, we need to have data set pertaining to that particular share.
Yes.
Where do we get it from? We'll have to prepare it by
No, so normally if you want to get any, say, historical data, usually you get it from BSc or FSC or Yahoo Finance. Go and type
or individual
yes,
share.
yes. You go and type in the slip code up to 1 year historical data, you will get.
I can show you.
This also real data ones.
Yeah. I know. On your Excel also, they are showing how to download real data. No. They are asking.
I get it. This is the list.
Yes, I know. You just type BSc there. No man. Oh,
That's science.
BSc.
Better go for the next.
No, it is simpler. That's what I'm telling you. No, both are same. For prediction, it won't make any difference.
Idea is it is user friendly to take that.
Not BSc, BSc.
BSc. Just
Yeah.
enable to them. H is not.
PDF also is capacity.
So you have different.
So if I want to have data pertaining to ASA, automotive stamping, automotive stamping.
Stock.
You see? What you said? You said
ASA, so automotive stamping.
AS?
AL.
Yeah. Is
No,
this?
Second one.
Which period you want?
2 months. Last month.
Say
January.
from Jan 1st to till date.
Fourth.
I think now also it is not showing. No problem. Now.
Today's
Oh, it is.
for today.
Likewise, you
So we have to go to the second month. Instead of daily, we have to go to monthly.
If you want monthly, then only get monthly data. Otherwise, if you go to Yahoo Finance, you will get decent data.
And there is another website called Screener.
Screener is this.
You can get historical data.
Munafra Sutra, screener, 5 pages.
Yeah, I think, thank you.
Thank you so much.
Wonderful interaction. We'll